Oh, that was a pop. Sorry. Didn't mean to do that to you guys. Yeah, I need to figure out something with this camera. This camera angle needs more motion. Things need to be happening on it. Maybe I'll move the on-air light. Move that back to the rack in the corner, because the rack in the corner has visual stuff going on. Maybe that's what I'll do. I think about that a little bit. How's it going, Brink? How you doing? All right, let's see here. YouTube chat. Let me open up YouTube chat. It's always a pain in the butt. Really need some API-driven stuff. Open up this chat, but I can't. My chat might be too active for the amount of tickets they give you. This camera is so glitchy. I don't know what happened to it. I just booted up OBS, so it can't be like a latency thing. Maybe the computer restarted itself at some point during the night because Windows is deciding to futz with everything. They say Windows 10 is, oh, we're totally done with Windows 10. Windows 10 is done. We're done. We're done. We're not touching it anymore. Here's an update. What are you doing? Stop poking your fingers in the pie. What's going on here? What's this one look like? Oh, calibrate that camera. It's a little messed up. Is it autofocusing? Autofocus? Yes. Yeah. Arm procedure. Yeah, it's not an intentional effect. It's quite aesthetic. It looks kind of cool, but it is absolutely not supposed to be happening. It's a little strange that it is. It's because of the massive amount of extensions that it takes me to get the Logitech camera signal all the way out to where the camera's stationed. And while I could get other cameras that probably do it better, the Logitech cameras look really good. They have good video, and they're cheap. They're cheap. Sometime in the near future, I need to look into getting better cameras. You know, pretty sure I'm serious about this streaming thing, so I should probably get serious about my equipment for this streaming thing. That I should also clean up around here too. There's some things that I really need to neaten up and sort of organize a lot better than I've got it. Right now, it's a big house of cards and it's stable. And one little poke and the whole thing. Said it never update from Windows 7, then vendors stopped releasing drivers and my graphics cards started bugging. Yeah, I was the same way with Windows. You know what? The switch from Windows 10 or Windows 7 to XP. Wait, is that the other way around? XP to 7. My laser printer stopped having drivers, which was really kind of a betrayal. I was so mad because that laser printer got me through college. XP to Vista. I didn't do Vista. I did XP directly to 7. And I think 7 didn't support my wonderful Brother laser printer. The Brother laser printer is awesome because basically it's a laser printer. Like there's nothing else to it. It's such an old thing, but man, that was so good. Oh, I hate this part of the mix. Can I please skip it? I don't like the weird ghost voice song. Okay, it just stops. Let's find a different mix. I gotta find a different mix. I gotta find something that'll be kind of wallpapery. I hate to call it wallpapery, but that's essentially my intention. Volume 1 of the Chill albums? No. Deckard Chill playlist. Oh, SoundCloud. Not particularly married to SoundCloud. It's just what I've been able to use. Maybe I should just search SoundCloud for Deckard's Chill albums. There we go. 50th birthday part 2. Fine, go. It's these guys, the Space Cowboys, that got me into all this. Well, it's actually the Philadelphia Experiment fellas that got me into the minimal house stuff. And then I found the Space Cowboys through a California buddy who was into it. And it's been just kind of a mainstay of just like, you know, obviously I love electronic music and I've listened to it my whole life. But I also, every now and then it's good to know what's going on in sort of the pop scene. And for a little bit, these guys sort of helped to inform me of that. So if I hear a reference to a particular song, I'm like, oh, I heard the Minimal House remix of that song. Nowadays, of course, all hell's broken loose and I have no idea what's going on anywhere. But Always been an early adopter for each Windows version. You are very brave. You are very brave. I was on Windows 11 on my daily driver about 9 months after public release. I guess it's nice to rip off the Band-Aid and just, everybody's struggling with this new OS, and you're like, oh, no, I know how to use it now. I've been using it for months. That just fell through the handle. We gotta put a fan on this. That was another option for today. Putting a fan on the back of that oscope. But I'm gonna opt to play with capacitors because it's scary. I am scared. I don't like playing with capacitors. These little bastards pop off, and you go, ah! And then there's cardboard everywhere. I think we successfully fixed Julian's module. I guess it just doesn't have, because it's using a 7805 voltage regulator, so it probably just doesn't have the authority to do higher voltages. It doesn't get up to that 10 volts. My work PC is an exception. I want that shit in the oldest LTS version. It's what is that adage about tech guys have like the oldest printer they possibly can, and they keep a gun next to it in case it does anything weird. I guess I'll just stuff this in here like that. Keep the cables out of the way, because we are still doing stuff with these things, sorta. But I want to do the emote kicker a little bit today, and a little bit with this high voltage stuff. Yeah, I always like that meme. Unfortunately, I am not that meme, because I'm putting all this Internet of things all over my thingy thing. So I end up with sort of the updates and upgrades that I don't do end up biting me in the butt and all that stuff. It's the whole world that I want nothing to do with. I'm thrust into because of the kind of stuff that we do here. I had a huge lunch. I really hope my glucose level doesn't reflect that. But it will, and I'm going to get grumpy. Well, if you control the Internet of Things, it's a bit different. Yeah, it's my walled garden of Internet of Things. That's true. I really want to integrate those Internet of Things into more stuff. I got the itch, but I don't have the time. I've not been doing my homework lately, guys. I'm not happy about that, but that's just the situation that I put myself into. I've not been doing my homework. I've not been working on circuits in the background. Fusion was down most of yesterday, which would have been hilarious because I was going to do a sponsored... We need to do our sponsored AutoCAD stream soon. I'm keeping this voltage regulator because it's thoroughly exploded. I was going to do a sponsored stream, but Fusion was down. What a terrible endorsement of their software. It's just the worst. They're like, why do we invite this guy? What's he doing for us? He's just bad-mouthing our software. Music is a bit loud. It's about as loud as I am. So yeah, let me turn it down. It does look like it should be a little bit less than me. SoundCloud is a lot louder than YouTube, and so I need like 2 different sound settings for them. I think I should be plainly audible over the music, and the music should be kind of soft, but also present. Unlike some streamers, they calibrate for headphones, and so the music is non-existent. It's like barely in the background, and then the streamer voice is booming. So I don't know if I should knock it up just a little bit higher. Local software doesn't work because their servers are being maintained. Yeah, that's... Well, okay, so you can work offline, but the stuff that I need to do is stuff that I work on between 2 machines. And then I'm going to get, for the Legion Go, I took that to a LAN party finally. I took it to a LAN party on Saturday, and the Legion Go did pretty well. Valheim was a little bit slow on it, but I haven't bothered to super duper optimize it, right? Because there's ways you could super optimize the games to run on that handheld. But what I'm thinking is that the handheld should probably work as a thin client. And so I'll have the handheld as a thin client for my big, massive, meaty, throbbing gaming computer, right? And so I'll just have whatever, like video coming back from that. Legion Go can obviously handle that in stride. And the like pixel art games that we play, I'll play on the Go itself. But I'm also going to get, if you guys are familiar with Linus at all, Linuxes, I'm looking at getting Bazite OS on it. Bazite OS. And then with Bazite OS, I'm thinking I might also put Fusion 360 on the Legion Go. And that way, you know, when I plug in hopefully I can plug in a mouse and keyboard. I think they've got that functionality. I don't think it's all on the controller. That would be torture. If I can plug in my keyboard and mouse and like an extra monitor, then I can do Bazite with Steam Link. That's exactly what I'm thinking about. Yeah, it's good that you guys are so smart in so many ways that I'm not. But I'm thinking that if I plug in a keyboard and mouse, I can run Fusion 360 locally on that machine, and it should be able to handle it just fine. Brown Bag, how you doing, Brown Bag? It's been a while since we've done heavy software stuff. This is going to be partially software-y. I'm back, and you can't stop me. Yeah, we failed. We failed. He's back. They're back, I should say. Sorry. 65 months. Hell yeah, Brown Bag Code. Thank you so much. Yeah, I can't code my way out of a wet paper bag, is what I always think about when I read that name. We are going to do stuff with capacitors today. Capacitors scare the shit out of me. If you guys have ever seen my one singular viral clip, you'll know my attitude towards caps. Now, I'm not generally afraid of every capacitors. I don't, you know, turn the corner and there's a cap sitting on the floor and I go, ah! No, it's not like that. It's just when the capacitor gets to be the size of a shotgun shell, I start to get a little bit wary. This is the size of a blasting cap. And if you've ever seen a blasting cap go off in a 50 caliber ammo can, you'll know that it goes about 35 feet into the air with something this big blowing up. So I really don't want to damage my hearing, damage my face, etc. We're going to be careful today. We're going to be careful today. I'm thinking Bazite because it's a more like handheld, like tablet experience. That computer is like, it's basically a tablet with two very cheap feeling controllers on the sides. The Legion Go. I like the Legion Go a lot. I don't know if it was a good purchase yet. I don't know if I really should have bought it. Like, I'm having all these regrets because it sat for like 8 months before we actually got to like do anything. Dirty Old Man. Oh, Brown Bag Code has gifted subs to Me On It, Dirty Old Man, Bimbo for Cocoa Puffs. Where are these people coming from? Bimbo for Cocoa Puffs. Yeah, I'm a little bimbo for Cocoa Puffs. Owen Morton and ADHD Generate. ADHD Generate is a friend. I would raid ADHD Generate a bit more, but he streams in like the middle of the night for me, so it's hard to get that connection. But he'll come in and just start ribbing me. Yeah, he got somebody that we know. So yeah, with the Legion Go, I'm thinking Bazite OS. I have to do a couple like sound fixing mods. Mostly going to be using Steam. I don't think I'll need any other launcher. It depends on what games we're playing. Maybe in the future that'll happen. But and then with Steam, I can thin client, you know, Steam Link or whatever back to the big computer for games that I want to run smoothly, games with graphics. But I mean, it should be able to handle Valheim. I think maybe with Bazite, a thinner OS on it, and the ability to kind of tweak stuff a bit more, I can probably get Valheim to run locally pretty well. Valheim's not that crazy of a game. It does have a lot of visual things for being low poly. It's low poly, but it's got a lot of FX going on. So there's a lot for a graphics card to kind of sink its teeth into in there. But then again, that it's a gaming laptop basically, so it should be able to do it. He lives up to his name with the hours he keeps. Yeah, absolutely. Absolutely does. The problem is that I know that, meaning I am keeping similar hours, and I need to stop doing that because I've got like a headache and I'm tired. I'm not in good shape. I really need to kind of clamp down on my sleep habits. I think maybe tonight is an early bedtime and no imbibing. Early sober bedtime so I can feel good tomorrow because I have a lot of stuff to do and I don't want to just sit all day. I've been doing that. I've been sitting all day. This is also what happens when my meds are interrupted. I end up just sitting down for the whole day. It's awful. What should we put the on-air light over here? No. I'll move that another time. We're doing breadboarding though, and I need to find my power supply for. Might need the power supply wires. I need to get my Nixie tube power supplies. What is this part of this cable. It's hot over here. Why is it hot over here? Probably because I'm running around. I'll move the fan. That'll help. Wires over there. Scrap goes back to the scrap bin. Don't need scrap anymore. Stereo wire goes in here. This one also goes in here. I'm gonna clear out a little bit so we have room. I bought the winch that I was talking about, and it's a little big. It's a little big. I don't need something this big. I don't know if I can find a smaller winch or if I should just go ahead with this one. I guess I should continue with this one just in case there's a reason to have something so large, but I was really thinking, like, I don't want to turn it into too much of a project. What I'm going to do is I'm going to take this thing, 2,500 pound winch, and I'm going to basically make it use one or two 4 amp hour or 5 amp hour DeWalt batteries. So this thing is 12 volts. I can probably hit it with 20 just fine. That'll drain the battery pretty quickly, but the other thing is the motor's rather large on this thing. I don't know if I could put a 3-phase motor on it. Probably not a great idea. I should probably just keep this thing the way it is. Certainly make it a lot more compact if I didn't have this giant universal AC motor on the end here. Replace this with something like a pancake 3-phase. That'd be kind of cool. Maybe we'll look at that today if this doesn't work out. What do those cost these days? What are the sizes of them? You guys need to be managed. Pull you guys over here a little bit. Loop, there we go. And then I need a Bower window. I need a browser window. Thank you so much, Brown Bag Code, for the 5 gifted subs. That's super kind of you. I'm working on getting something that'll react to subs, something new that'll react to subs. Today we're going to be working on a solenoid kicker that's going to launch these little plastic emotes in my face. So, you collected all the level 1 emotes. Yes, I know that. Hobby King. And what are my dimensions on this thing? What are my dimensions? I want something that's going to be as wide as the motor is currently, just at least from an initial standpoint, an initial overview of what I'm thinking about with this thing. I mean, I probably paid for this motor. It's probably most of the cost is for the motor. 8 centimeters. So our upper limit is 8 centimeters of width for the motor. Let's see what we got here. So, push notifications. Hell no. What, has anybody ever agreed to that in the history of the internet? Power systems, electric motors. These are so expensive. Bargain bin. That's an instant click from me, dog. How do you size these things? Oh, bring me back to motors. Good God, this website is like pulling teeth. I have to double click back in order to actually go back. Oh no, but then it grabs me. What the? Who's coding these websites? They're terrible. Electric motors. Brushless. How in the hell am I going to navigate this? I need to know what the terms are, and I don't even know the terms. Warehouse, Branderlech, Global, USA, search for product, 800 millimeter? No, that's 80 millimeter. Oh, God. Not feeling that. No, we're getting into the realm of like non-hobby motors. 80 millimeter Outrunner. Something like $65. That's not too bad. 750 kV. Brushless motor. I don't know. It could have just ignored all of my terms. for multi-copter. It would be like a giant multi-copter. 360 kV. I don't know. It would be really, I think this is much smaller than we're looking for. The motor's going to be, that was $5. Are you kidding me? I gotta really search for a motor then if I'm gonna do that. The universal AC motor is great at all, but putting in like a brushless will make it significantly smaller and lighter and more compact with the same 2,500 pound hardware that it's got. Although it will have a reduction for a universal AC motor and not for a drone motor, but that's why you go wide, so it's got more torque. We're not too concerned with speed, I don't think. Although it's probably going to have a pretty big gear reduction. It would need a larger one. 80 millimeter archives. These are very similar to the ones that I already have, the ones that I would like to use on the future Burn the Subs, not the, or no, on the CNC machine, actually, we're going to use those. The ones for the CNC machine that I've got going through gear reduction already. But those have been servo-ized, and they're kind of special, and I don't want to use one of those for a winch, just a simple winch. I want to find like a cheap pancake, one of these things. Something like crazy like that. 135, yeah, maybe not that one. Jeez, look at the size of that though. That's hilarious. That's crazy. What is the powertrain? That's just a big piece of aluminum. Wow. Sunny sky. Yeah, and the other one is how much am I going to end up spending? Maybe I just leave it as a regular old winch and I just put a block on the back of it so I can hook it up to the tire rack that I want to use to lower tires down. And now it's like super flat. Well, 6,000 RPM, 80 millimeter series. I don't even know what that's about. You could search Google Images. It's hard to do this kind of stuff because there's so many sources. Yeah, see, brushless and 80 millimeter is going to be coming up with big servos, not a universal AC motor type thing. That's got a picture of a flying saucer. Maybe that's an instant winner. Oh no, it's a ducted fan motor. Never mind. I don't need that. Don't need that. I wonder if the little one that I have, the green one, I wonder if that would actually work in this system. That's like hilariously smaller than the universal AC, universal DC motor. Hilariously smaller. I don't know if that warrants a replacement. We'll have to take this thing apart at some point then. Here, bring it over here just to take a look at it. This was like the cheapest one that they had. I'm sure there are smaller winches that I could have motorized, but this one has a motor. I think it would be kind of cool to, instead of having this big boy here, I could put like a little tiny guy on it, and then it would be more, you know, it'd be like that. But this thing will definitely haul stuff vertically if I needed to, so maybe I just leave it alone. Yeah, it's got a big steel plate there. This is metal. Gearbox is probably inside there. It looks like this whole housing is metal. The motor might be built into the housing. Ugh. I mean, the two here will probably release the back plate and give you access to the brushes. The brushes might be under this. Or they might be part of the terminals. They're probably part of the terminals. Huh. So, technically, I could probably get rid of all down to here. And then somehow put the outrunner on it. That'd be kind of neat. I guess I'll just leave it dumb for now, though. For now, it can just be dumb. I also have some gearboxes from drills. Maybe those would come in handy, too. Try to put more reduction on it so that the little outrunner motor can run like at high RPMs. This thing probably runs at decently high RPMs in order to winch this. If you could do 2,500 pounds, you betcha. Yeah, maybe I just leave this the way it is for now. Maybe I just leave it the way it is because, you know what? It ain't broke. And I kind of, if I want to put winter wheels on my car, I'll need this thing to be in one piece. But I am going to try to power it using the DeWalt batteries. What are the input specs on this thing? It probably says 12 volts only. Do not disengage clutch under load. This is meant to go for like an ATV. Min 8. Pull. Read manual. This is a pulling device only. Do not attempt to lift item with this winch. Huh? Wait, what do you mean? I am going to attempt. That's exactly what I'm going to do with it. I'm going to lift the wheel up because I don't trust myself on a rickety ass ladder. This thing is going to be vertical. It's going to be for lifting. That, or I attach it somewhere below and put it through a block. That's probably the smart way to do it, huh? Put it down low and then put a block on it. Up top. I don't know though. Like, they don't say what voltage this thing is. I guess, you know what? Under 20 volts, a motor this big will probably do just fine. Probably do just fine. We're not going to be Batman with this thing. I'm not going to be able to just put it on my belt and fly around the city, but, you know, I can lift the wheel without falling over and dying. All right, we're going to be snapping this thing using whatever big caps we can find. I don't have a ton of huge caps, but these are 200 volts on this thing. We got 3 of them. They're 330F. That might make a significant amount. And then we're going to use a Nixie tube power supply that I think will supply 60 volts. And we'll put a big resistor on that so that it doesn't charge it up too quickly. We observe it charging, and then we put it through another one of these little motor MOSFET blocks so that we get full isolation. I'm not going to muck around with diodes or anything like that. What I want to do is charge it up, isolate, and then punch off the caps. And we'll do that using the microcontroller as a coordinator. Because I think these MOSFET things that I bought, this big pack of MOSFETs for motors, I think they're pretty good. If only it was that easy to create Batman gadgets. Yeah, no, seriously, that winch is crazy. The animated series one. How do you fit all that in a handheld device? I guess if you got Bruce Wayne's budget, you can figure it out. Mythbusters made an attempt. They did pretty good. Using pretty much just a drill motor, right? And you could probably use some of these more modern motors on something like that. I wonder what kind of a Batman scaling device you could make nowadays with like heavy CAD and technology, with like one of these YouTubers with that full CNC setup and all the CAD tools and stuff could do some calculations and try to make something that lifts you. There's a lot of energy in that though. That's the problem, is that if you're going to lift a human body that quickly, there's a lot of ripe opportunity for all kinds of unique injuries with that kind of energy behind something. Nuts. It'd be nuts. I know some people have worked on it, and they're generally pretty janky devices because they're like very heavily DIY'd. Spacers go down here. Clean up a little bit. I want to have somewhat of a clean desk for this because I really don't want to get punched in the face with a capacitor exploding. My logic is sound, right? I've got high voltage capacitors, and I want to bank them up. I want to put them all in parallel. Then I want to use these MOSFET boards to connect a 60 volt power supply through a big resistor. The big resistor is in there as a current limiting device because the power supply wants to put out as much current as is necessary, and even if it's a short circuit, it'll put current through it. It's a very low current power supply though, because it's only supposed to be lighting up neon lamps. So I'm going to put a big old stinky resistor in the path that's going to limit the amount of current, allow the power supply to output its mid level of current. We're going to have to do a little calculating on that one. And then presumably, maybe we got to look up the chip again, because I think these are 45 volts. We're going to be dealing with 60. These are 200 volts, so they're well within their specifications. And then when we want to pop off, we disconnect the power supply and the current limiting resistor, and then we connect to the solenoid directly across this mamma jamma, and that'll pop it off. Current runs out, it comes back, and then the flyback resistor or flyback diode does its thing. And then we can repeat the cycle as needed. The capacitors will stay discharged most of the time. That's the idea. Yep, exactly. How's it going, Thurvy? You know, you give the fans a way to interact with you in a way that's just a little bit rude, and all kinds of names come out of the woodwork to suddenly interact with your stream. Not to single anyone out. All kinds of names that I haven't heard in a long time are suddenly back now that I have a machine that will fart on my desk. Funny how that is. Ha ha, funny. The other thing that we could maybe do is work with MakerBeam a little bit. Build something with MakerBeam in order to hold the solenoid and kick the emote out properly. It's also possible that we could use a smaller solenoid. Been sick for a few days. In that 70% recovered meh state currently. Oh, I hate that. That fills me with anxiety when I'm like that, because it's like, I need to be getting stuff done, but I'm sick. Recovering is getting stuff done. Well, I'm glad to hear you're on the mend, at least. Not clean enough. I need it to be cleaner. Sir, it's already too clean. We can't handle it. No. I need more cleanliness. I need it to be cleaner. I don't know if we're going to use the power supply at first. Getting the timing right is going to be interesting, although seeing whether or not the fartalanche, yes. Imagine how many people would come back with BTS. Yeah, I know, man. Look, you guys don't need to be reminding me of this monument to my inability to work on stuff. It's literally mounted on my wall right in front of me all the time. I get no love from you guys on that front, huh? No love. Nobody can relate. Toss this stuff all the way back. All right, that's pretty good. Decent enough. Decent. We need to make a big cap bank. We're going to need to find some wires. Get more of these things too. You want a BTS update? We've been working on stuff that relates to BTS. The thing that we got working most recently was a big sort of roadblock. It was a big hurdle for me. I just couldn't figure out how to make it work. Fatanon sat down with me of his own accord. We didn't plan anything. And walked me through some of the process of getting the node red node that I wanted to work on Twitch's event subsystem. So now that we have cracked that code, I guess, and we now have access to the Twitch event sub through node red, I now have my chat interactivity back, and it's got one single entry point. Hey, Solid Electronics, thank you so much for the 27 months and the fart avalanche that subsides, that comes along with it, I guess. Yeah, so anyway, the other one filled up. It had 6,000 exactly. It's like 6,001 or 2 names on it. I forget exactly which one it was. It's in the VOD section of the YouTube if you want to check it out. But it filled up. It got one big long name that just killed it immediately. So that board is full, and I've already mounted it to a stand that sits behind my desk. So I've got both boards on this big stand behind my desk. I still need to finish wiring up the LED lights for that. They can be illuminated and it'll look really nice. That should be something that goes alongside of my desk, not behind it, but just because of the way the room is shaped, I can't do that. If it was alongside the desk, then for the game streams, I would have the boards sitting right next to me, and that would make a really nice little aesthetic. But anyway, so those 2 boards are filled, and it's been a long time. It's been years since we've had a working burn the subs. I took it upon myself to take everything down and do something different this time. So this time, burn the subs as it exists is a live edge board. Now this live edge board is not exactly what I was looking for. We went to some guy and he gave me a deal on this. This is a $300 piece of wood. I don't really think it should have been on some. I probably could have just gone to Home Depot and looked at their crappy live edge, because I kind of wanted to have a little bit of bark on the edge and stuff. But we're gonna make good with this one. We'll make it work. And I don't know what I'll do with it afterwards. Maybe I'll sand it down and do another board, or if I could find somebody with a horizontal bandsaw that's large enough, maybe I can get a cut in the middle of this, because this is like a park bench. This thing I could turn into a seat. But anyway, we're going to use this block of wood. It's a little limited in space. I have an idea of what the graphical parts are going to look like. But then we've moved everything over to a new control panel block. So this is water cooled. It's got a water reservoir at the top. It has the pump at the top as well, because that's how you water cool stuff. Then it has the Raspberry Pi. It has a VFD character display, and it has a bunch of power supply stuff in there with a 3D printer control board. So it's got the TMC, the good TMC drivers, the ones that can do bump stops instead of having switches. So we still need to rewire all this stuff. I've got a comprehensively 3D printed side panel that's got the cutoff water connectors for the laser, and it's got the power input and the switches on the other side with a breaker. It's got an actual circuit breaker, a DIN rail circuit breaker. There's a DB25 over here for the interface to all the physical stuff. And those water lines will go all the way out to the laser, where we have a 3D printed jacket over the chromed laser carrier thing. So we're basically running water on a heatsink that's connected to the laser. Why? Well, because we can. Water cool the Raspberry Pi, water cool the power supplies inside of it, and then why not just run water all the way out to the laser itself? So we had a bit of a struggle there water sealing a 3D print. I figured out a way to do it with ultraviolet epoxy, but I also then got a goop printer, a resin printer, which could probably make a clear version of that that would be sealed from the get-go. So, work continues. The power supply is a solid-state power supply that I've never turned on. So one thing that can really shoot us in the foot is when I turn this thing on for the first time, it might squeal and make all kinds of terrible noises. So it's possible that I put some kind of an LED display behind this little grating that I made, and then have some kind of just like a pattern running on that. And that'll just suck up a little bit of amps from the power supply and keep it from squealing. Because that's what happened with my other Vicor stuff. That was an eBay buy, by the way. eBay buy, by the way. And oh yeah, and the solid state power supply, we made a little tube that goes on that heat sink. So we're running water through the solid state power supply's heat sinks. And it's got one tiny little radiator up there with a fan on it. For the mechanics, I totally redesigned the laser carrier. That was a huge Fusion 360 model. A lot of opportunity for this thing to go totally wrong. And then, let's see, we made new mounts for the things up top. We're sticking with the same mechanics just because it's a very big area to deal with. I would like to put the drag chain up top, but I don't know if that's going to happen in this iteration. And then this drag chain vexes me. If I put this drag chain up top, I could have this one hanging down, and it wouldn't need something to keep it from bowing outwards like this. I don't like that. I really should have done from the top down, but that would then change where these are coming in, these water lines. I guess the water lines could just go up, but that would be kind of weird. It'd be better if the water lines connected way up here. So many things to worry about. Oh, and then the electronics themselves are behind a glass case. That was a clock that my brother built in high school. Grade school, actually. It was somewhere either in the early 90s or the late 80s. He built that box, so. Fill up. They make custom coolers for TO220 MOSFETs. I do not. Look. Like, usually what you do is you just find a heatsink and you throw it on there, and then you put these with some isolation on it. This heatsink has screws going through the bottom and a fan on the side, and if you wanted to water cool this heatsink, you could just stick a copper tube on it. You just wedge a copper tube in there. Because, yeah, they'll make anything, but Well, FET cooling is like the latest thing that people are doing to their motherboards. But really, you don't need fancy stuff. Because all these blocks are a bunch of tubes that have been squished into aluminum, right? You could make that with a vise and a CNC mill and a good tube bender, I guess. One sec. Machined acrylic water block. The acrylic thing, I could take it or leave it. It's good to know that where the bubbles are, I guess. Good to know where the bubbles are. Yeah, the switch to Chrome. My pulling out and pushing in tabs is a lot smoother in Chrome. Firefox could smooth that process up a little bit. It still works in Firefox. It's just not as smooth. What's going on YouTube? Nobody's around. Usually we get like a Madamu at this point. One concurrent viewer. All right, well, whatever. It's not about the viewers. It's about the archives. Yeah, this is another Deckard. My definition of chill. This is his 50th birthday set, part 2. But this is Deckard. I listened through SoundCloud. It was originally through Space Cowboys, but they do kind of like poppy stuff. Yeah, it's just, yeah, Burn the Subs has sat for too long. We've worked on it in bursts, and we've come a long way with it. So the remaining stuff that I need to do, I know what it is. At some point, I need to move all the cameras over to that bench, and we need to have a stream where I basically just sit on the bench and wire this thing up. It's all going to go to a DB connector by the control panel, and then we'll need to figure out getting those tubes all the way out to the laser itself. That's why I was kind of debating about flipping the drag chain over. Would it be that big of a deal if I only flip the drag chain that goes to the laser? Well, that would mean that all the wires need to go all the way up and then through the drag chain. That's a little bit weird. That's a little inelegant. But the problem is, if I were to move the lower drag chain up, I would need to move all of the frame rails up too. The rails are what connects it to the baseboard, which is 2 pieces of pine wood. No, it's 2 pieces of... Yeah, it is pine wood. It's pine, 2 long pine runners that are screwed into the joists, into the wall joists. Is that what those are? Is those called joists? I think they're called joists. Whatever the vertical boards are that make up the inside of the wall. We in America, we got drywall. So you get through the drywall, and then it's just board framing. But so anyway, the pine wood screws into that, and then Burn the Sub screws into the pine wood. And that's all leveled and straightened and all that stuff. But let's see. Oh yeah, and then the board itself, the wooden board, just has those vertical pieces of pine, and those screw into the pieces of pine in the background. And I put some plastic up, black plastic up, just to hide the wall. All kinds of layers to Burn the Subs. It's a very multifaceted kind of thing. I guess I'm not min-maxing the space because I could move the larger stepper motor out of the way, and that would maximize that horizontal space there. But this board was just about the perfect size. I think we had to cut it just a little bit. I got a lot of decisions to make on Burn the Subs, don't I? With the new drivers, we can just have those aluminum blocks be what the axis crashes into in order to figure out where 0 is. So we'll just crash it on both axes. Technically, I could maybe... could I do the drag chain up top? I don't think so. I need that extra space. What's up, Gonad? Just looking at Burn the Subs quickly. I got a winch. I got a winch to get my tires down from the top of the garage. I got those tire rack tire mounts, wheel mounts, where you can hang your wheels up vertically. So we put them above the garage doors, and and I haven't gotten them out since. But it's getting to be about time for me to switch to technically winter tires for the summer, just because the wear that I'm experiencing on my summers is pretty extreme. So I got this ATV winch. This would be a lot more useful to me if I could cut this motor down significantly and put something like an outrunner over here. Although I don't know what kind of RPM this thing requires, and it probably has a long shaft and all kinds of stuff. My summer tires lasted all winter time for some new ones when the weather is nice. Yeah, that's the thing, is I think maybe I'm just going to be out a few $100 to get new summer tires. Just because this winter was brutal, but the previous winters have been extremely mild. I don't know if we're going to be getting brutal winters as like a thing. But yeah, what I want to do with this is I want to attach it. I want to clip it up top where the wheel rack is. I mean, I could either do that or I could screw this into the wall with some big screws. That could work too. But then I'm going to put DeWalt batteries on it. And then put like either a block up top, or if this thing is attaching directly, who knows. But then I can clip it onto the wheel, lower it, and I could use something that'll let go when the wheel hits the bottom. I've got a thing that's not over there. Where is it? Well, I'll have to find it. I've got like a little like pincer thing where it can hold on to weight, and then when it gets to the bottom, it'll open up. Yeah, for lowering the yeah, this is for the ceiling lathe. You freaking jerk off. Lower the ceiling lathe, the 2,500-pound ceiling lathe. I guess it could lower something. I don't know. I'm not gonna do that. Need 4 of those for the ceiling lathe. I don't know what lathe you guys have in mind. Everybody's so insistent on me getting a lathe. The Nixie tubes. One sec. Let's get those out. Oh boy, that's gonna cause havoc. Okay, hold on. Get this thing out without causing an avalanche. An avalanche. I paid $25 towards the lathe, I thought. It went to other parts of the shop. It's very important. Money has already been allocated. Never did anything with this. This is a Nixie tube driving Arduino circuit. Could have been pretty cool. This is the power supply. We're going to use one of these. I got a couple of them. This might be the one that we end up using. I don't know how many volts this thing is. 85 to 235. That might count this one out. 85 volts is a little bit above and beyond what the specifications are for the MOSFETs that we're using. I don't want to have to go over to Triax. 1 UF 240 volt. That came with a little power supply. This one has leads on it already. All right, we'll use that one then. You can go in here. You'll be safe, I guess. These are other things that I've wanted to use. These are Magic Eye tubes. Magic Eye tubes. These apparently do a cool little dance with audio. You can look them up on YouTube to see them work. And then I've got all these VFD tubes that I've wanted something to do with for many, many years. I'll have to make like a screen with it. But in order to make a screen with it, that's a lot of leads. I have to do a lot of leads, and then I have to somehow charge this thing up and get it to work. Magic Eye tube often used to show tuning in old radios. I thought the display wasn't all that reliable for like what it does. Look at that thing. Crazy. This is an eBay special. It's every now and then you look on eBay and you find stuff that people don't really know what the hell like they have. You just order it from them. This thing is a dot module. Oh wow, camera's a little weird. Hold on. Setup micro procedure. This thing is a very strange tube. It you give it a signal like a pulse, and it'll count the pulses sort of around in a circle. I don't really know how to use it, to be honest. I was gonna put it in a computer project, like a computer case that just had this like HAL eye that does weird county stuff. I'll find a use for that someday. These are all things that can go on like a curio shelf. Oh, these are rare. These we've done stuff with these before, and they're how I got my badges. It's basically a symbol display. So instead of numbers, you get ohms, volts, S, whatever S is. Pretty cool. They're very rare. Well, they're rare. They're more rare than the regular Nixie tubes. Nixie tubes aren't terribly rare. This one has volts. Oh no, it's this way. Micro volts. I think that's it. Yeah, that's an A. I see ohm in the background. I think this is like a multimeter module, a multimeter module. Oh my God, I get it. I get it. Your music. You've identified yourself as music. We know it's music. Oh my God, they won't stop saying it. We get it. Stop saying music. Oh my God. These are the slightly more compact ones. This is a fun bin. These are a lot of very interesting, weird kind of displays in here. I've got the weird Nixie tube bin, and then I've got the weird LED bin with the LED displays. But one of the key things with these Nixie tubes is that you can get vintage Russian Nixie tube switching modules. So these work at 60 volts. They're ceramic chips. They basically make this thing into like a solid state device where you just give it a BCD formatted number. So you give it 1011 and it'll light up that number pin. And so you can connect those directly to the pins of the lamp modules, and you can just run through them with like a microcontroller activating the different channels. They take 5 volts into one input and they switch the higher voltage tube volts to the other. Cool stuff. We're gonna have to figure out what these power supplies are. Oh, yeah, and if you want to look up these parts, they are 8910 is pretty much Russian IC 8910, and you'll probably find the right thing, maybe. '89 vintage. 8910. Yeah. Oh yeah. If you look up 8910 vintage. Yeah, they might be Soviet parts. Probably. All right. I had a big salty lunch. Oh, glucose level is actually not too bad. Well, I don't expect it's going to be leveling out. It might keep going up. I gave a lot of insulin, so. What up, lawn dog? Been lightly snacking for the last 40 minutes. Lantis is creeping in. Yeah, I had a big lunch. I should be eating small amounts over the course of the day. That's probably what I should be doing. Actually, I need to schedule about 65 doctor's appointments. I need to do the iron in the blood thing. I need to do endocrinology. I saw my regular doctor recently, so I don't need to see the regular doctor. I need to see the retina specialist. Oh my God, I got all these appointments that I got to do. This is usually, so you try to schedule these things, and if you're a miracle worker, you might be able to get them all on the same day, but they're in different buildings in different parts of the city. And so typically it's like impossible. So what I do is schedule one appointment on a day, and it's like I'm gotta be in the suburbs for this, or I have to be in the city for this. And so I wasn't able to get into work that day. And so I take my vacation time, my precious disparate little tiny piece of vacation time, and I'd use it on that. And then the company had the audacity to get mad at me for it. Bitch, I'm protected. I have a disability. Shit. Yeah, I got to see an optometrist because I got safety glasses that have a glasses insert. so I can actually see while putting them on. It's primarily for the gun range, but I would like to get my prescription reevaluated because I don't think my eyes are the same as they were when I got this tested. But I want to find a place that has the automatic one. That's that automatic, like Carl Zeiss, whatever the hell it is, where you look at the balloon in the field or the house or whatever. You just look at the thing and it just goes beep. Okay, I figured out your prescription without having to ask you if lens A or lens B is better. They lasered the ST logo. Yeah, it's an old. I don't know where I just put it somewhere else. That's an old one. That's a seriously old transistor. Probably still works. We're gonna get super close. Hold on. Closer than we're comfortable with. That one's the 7805. We're aware of what you don't have, lady. The power of microscopy. There it is. This is your 7805. I've got to not touch the desk because my heartbeat will move the camera. That is a 7805 that met its unfortunate end when Julian somehow managed to circumvent the keyway in an IDC connector in his synthesizer. What they say about inventing a better idiot is true. That is a text-only joke, and I'm going to leave it as text-only. You have Borb emotes? That's way smaller than I thought. Yeah, it says that's actually larger than I thought. Yeah, the 7805s that I have are at least from the 90s, possibly the 80s. Some of them might be from the 80s. There's a chance that some of them are even from the 70s. I don't know when the 7805 was exactly invented. It has always and will always be. It's not my favorite voltage regulator, but if you need 5 volts and you need a good bit of it, it'll gladly provide. Talking about better idiots, and here I am, says Mahalo while subbing for 67 months. Thank you so much, Mahalo. Yeah, I apologize for not streaming yesterday, everybody. I had one of those nights where my insulin pump wakes me up at just the wrong time, and so I just didn't sleep. And I felt like utter crap in the morning. I just had a headache, and everything sucked. I have a bag of 1987 7805s from NES boards. Nice! Yeah, I have a feeling some of mine are mid-80s vintage. They look like it. They were from a lab that had existed for quite some time. That was shutting down, and I helped, pack up. Does my audio look like it's not holding on? No, I guess it's working. Does it sound like somebody's manically turning up and down the volume knob on me? I guess that's the smoothing of OBS, so. A metal can 7805. Damn. To think that the force of the chip exploding was enough to shear off all that material. Old 741 op amps that are older than I am. No doubt I have, well, at least, just from the bin we just looked at, those Soviet Nixie tube drivers are likely older than I am. I'm not young. Unfathomable. All he thought he was doing is turning on his synthesizer. And something as complex as this took one look at it and said, yep, I'm out. And exploded. Just was done with it. And it sheared right across sort of the middle-ish of the die. If it, well, actually, if that was square, then that whole right side or the whole bottom side is sheared off. I don't want to touch the desk too much because it's really hard to maneuver. Speaking of the 70s, Jesus Christ, where's this mix going? So all the excess heat that this creates in order to regulate the voltage gets dumped onto that substrate behind it. But that substrate is encased in the epoxy packaging, which means the heat doesn't have anywhere to really go. It'll come out of that ground pin, but you can't really, I mean, you could put a heat sink on the epoxy and try to clear off the heat that way, but it's not as direct as a metal tab. You need an XY job to go on top of your stand. I've seen people with stuff like that, yeah. Or you put the stuff on the table on a little XY thing. Some of them even rotate. Those are really expensive though, because they use these like high quality servos to do it. That's for like people with like real labs. We can read 5 and we can read TR. I wonder what the TR is for. I know what a tiara is for, but I don't know what the TR, the lettering at the top of the die. The die. It needs servos that need to be chat controlled. What did you quote? So this is, oh, this is going to be, okay, it's hard to see the whole, the front end. This thing just naturally wants to flip over. Whoa! What have you been soldering? Dear God. Okay, back over to here. Pretty crazy. I mean, giving chat an XY thing is like, what are they going to do with it? They just move it around. Kind of stupid. I don't really think anything good would come of that. Oh, yeah, I'm not supposed to do focus from there. I do focus from the table. That's much easier to control. It doesn't shake all over the place. Look at this, one finger on the bench. See that? That's my heartbeat. Boom, boom, boom. Well, actually, when I say boom, it shakes even more. Yeah, we'll be doing some electrical stuff. Look at this. One finger on the desk, and you can see it shaking. That's one finger on the desk. Control group. Now without the finger on the desk. Insane. Part of the problem is that all this weight here works with the magic arm mount. The original magic arm mount is meant to hold a probe. And so if something crashes into your probe, you want it to kind of give. So there's a little spring system that holds it down in one position. It's loose in one direction. And so this lens is actually inherently pretty loose on the end of the arm. Plus it's on the end of a long arm. It's on the end of it's a magic mount for a probe. It's not really meant for camera systems. A lot of the macro camera systems, you'll see like bellows on, and you'll have adjustment control for how much the gap is to the camera. You'll have sometimes your lens will be flipped around, and then the whole thing will be mounted on this really, really solid x-axis or z-axis, I guess, and can then be moved up and down with a crank. We don't have that here because we want a little bit more malleability to the camera setups. And so if I want, I can reposition this thing to wherever I need it to be. Yeah, it's not. This is the trade-off. The monkey's paw has curled, and we have our beautiful microscopy camera system that is 2 feet off of the desk to give me room to work. But the curl of the paw is that it shakes. It just does that. I can't prevent that. Another thing I could do, mount it to the ceiling. If I were somehow able to mount it to the ceiling, well, but then people walking around upstairs would disturb my microscope image. So I'm not in a brick facility. A brick wall facility or a cinder block wall facility, you could attach it to the wall and then it would be super stable. But that's not what we have here. We have American quick construction from the 90s. So everything is framed in wood. It's got drywall on it. Eliminating joints also helps, but it's hard to do when it needs to freely articulate. Well, you know, the Magic Arm mount is perfect because I can just very quickly change my microscope setup. I think what I have is completely ideal for this type of stuff. When people ask me, what kind of microscope do you use? I'm reticent to actually, oh, it's not in view anymore. I'm reticent to suggest anything that I use because this is all very specific to Obava's show. Getting the angles with this stuff because I've got this thing movable. The face cam is the same camera as the microscope. The microscope has just the right kind of lens that happened to be an extra one from my DSLR back in the day. All that stuff is, yeah, it's very custom and it's very much Obava's needs being met. Whereas if you're going to work on electronics, you might be fine with a Raspberry Pi camera or maybe just some kind of a C-mount thing that you get from eBay. So there's all kinds of options out there. It says James 3 on it, but I don't know what voltage it is. That's the problem, is I don't know what voltage these things are. What the idea for today's stream is fairly simple, right? We're going to charge up capacitors through big resistors. We're going to get it up to voltage, and then we isolate out the high voltage stuff, and then we suddenly connect it to the solenoid and the solenoid clips. That's a very clear thing, right? The unclear part of it is my ability to create those high voltages. I can make 52 volts with this power supply. Push comes to shove, we go to that power supply and put a big resistor on it. But otherwise, I would like to use these Nixie supply tubes. These are designed to power up neon lamps. So I would assume that we get something like 60 volts DC out of this. I don't know. And again, I don't want to hurt my $1,000 oscilloscope, so we're probably not using that. I know the Fluke multimeter can at least give us somewhat of an idea of what's going on. I like how the new system like points directly towards whoever set off the fart. Ended up buying a proper aim scope stereo microscope. Is that one of the ones that has the spinning lenticular lens? Those are awesome. They're so cool. The Scorpion, I think, is what one of them is called. It's like an inspection scope, but there's a microscope version of it. You can put a camera on it, although all this stuff is industrial equipment, so it's all super expensive. It's super duper spendy. If you can sometimes find them on eBay and stuff, but what that system with ring lights and about 50-pound iron slab base, nice. We had the ones that articulated and they were attached to the back of the desk. This was at the FBI, and the hood, it's just this like hood that you look into, right, with both eyes. There's two lenses at the bottom, and that lenticular lens spins and it gives you all these different angles. And so when you look into the thing, you've got stereoscopic vision. You can see the depth. You can see how far your soldering iron is from the thing that you're soldering. It spoils you rotten because your back is straight. You're looking into a thing that you're not like hunching into two tubes. You're just looking into a hood. And then you can work at the bottom with it perfectly. 2 eyepieces and no articulating lens. Those things are awesome. And I was going to buy one, but they're like $800 on eBay. My system is very similar to that, though, except that I only have, I have an eye patch. I'm only viewing it without stereo vision, which means that sometimes I don't know what height the iron's at, and I'll end up poking myself as a result. This is a chill mix, but suddenly it went into garage. What's going on? Garage is not chill. Garage is music to like bounce up and down. Garage is the kind of music when you get an extra fish stick in the basket. It's bouncy. So I view this monitor when I'm soldering. So I've got a nice big view, and then the stuff is down here. So my back is straight. I sit up. I sit completely up when I look way too much like Drummond from Severance. I need to get a haircut. I'm channeling Drummond, and that's not a good character to channel. Use smaller words. He has a super deep voice, but I don't know if they're doctoring it. What's up, Celia Russell? I have a DSLR 4K camera attached to it, so most of the time I'm just watching a 28-inch monitor. Ah, I see. You don't need the stereo vision for that. Yeah. Did you work in the FBI office, or was it a separate location? I did not work in that building. Funnily enough, though, we were on the email list for the main. Is it the Eisenhower building? Which building is that? Whichever the main FBI building is. At least when I worked there 10 years ago, the emails that we got from the main office were hilarious, because it was always like, the 4th floor supply closet is currently underwater. Please avoid the 4th floor supply closet. And it's like the 5th floor lounge is currently on fire. Please avoid going to the 5th. Like, that building is falling apart. They're doing an extensive amount of work on it. I'm sure it's probably better now. But back then, we would get constant updates about what was broken in that building. But we weren't in that building. We were at Quantico. So in the middle of Quantico, there's where the Marines train. It's basically State Park, Marines, and then the FBI. And the FBI has their big like test track. They've got Hogan's Alley. They've got all kinds of stuff there, and we were part of that stuff. We were not in the main technical center. We were an offshoot building that was next to the main technical center. So we were as relegated to like the corner of the room as possible. But it was pretty cool. You would get to work and you would hear hundreds of gunshots, or someone yelling and then hundreds of gunshots, or tires screeching and then hundreds of gunshots. Because it was either the Marines or the FBI training some kind of a scenario. Trying to make a fancy UI for an e-paper display. I've learned that I hate UIs. I like them. I love using them. I love interfacing with them. But designing them is goddamn near impossible. At least on microcontrollers. There are some systems that you can get that'll just like help you do it, right? It just like helps you. But then you've got to learn that, and it's like its own separate language. Were you commuting to quantize? Yes, I was quantizated every day. If your car was out of inspection, they hate you. They hate you if your car is out of inspection. Those military checkpoints, oh my God. I thought the guy was going to jump in the window and beat the shit out of me. And my inspection wasn't even up. In the last month of your inspection, they start harassing you. Fancy UI for an e-paper display. So tempted to just be lazy to use image magic on some web server to generate a new image every 10 minutes with all the data I need, rather than try to write Arduino code for years. This is where the tech bro thing kicks in, and the next suggestion is, of course, Chat GPT, right? That's how these conversations always go. Why don't you use AI to facilitate your code writing? I can't do UI UX. My IQ becomes lukewarm as soon as I need to start picking out colors and things. See, I could do some of that. It's just like getting the whole framework together is what kind of, at least I'm sort of dragging my feet when it comes to the module tester module. AI makes for a really good reference manual. Yeah, that sounds about right. It's not a drill sergeant. It's some security guard who has to sit there all day. Actually, they're pretty busy people because there's a lot of cars that go in and out of those bases. But they also, like, to get to the national park, you have to show some form of ID. So they're checking regular people, but then they're checking people who show their classified, IDs or whatever. Why, this sounds like a great job for Microsoft Copilot. I don't exist. I'm not a real person. This mix is getting good. I have a problem because I want to kind of get started, but this mix is getting really, really good, and I want to hear where it goes from here. It's actually kind of long, though. Are we overtime for? Oh, yeah, we're way over time. Oh, you got a lot to talk about. And we're doing cool stuff like looking at this thing. And I don't have Start Soon up on the thing. So technically, maybe we've already started streaming. You never know. Why are my thermals not on? Those have been failing. The computer restarted. That should totally work, though. Oh, I think this is a... what do you call it? Some kind of a band remix. Oh, that's the wrong one. Where is terminals? Properties? Deactivate. Activate. There we go. Now I got Hedo Vision. That still works. Radiohead. There we go. See, when I didn't try to force myself to think about it, it suddenly came to me. That's one of those. That's the nature of those brain farts that I have on stream. I am a singular host here. I am talking to you guys, and I'm the only voice that you hear. I'm the only thing with a microphone on. If you're on Twitch, you can hear the music going right now, which kind of helps me a little bit. But I have the singular focus of all the attention spans out there, and so I am tasked with continuing the verbal onslaught and the entertainment of this stream. When I have Julian over, I get to be quiet every now and then, and that helps me immensely. The brain gets exhausted, and I end up not being able to recollect very simple things. I'm sitting here like, what do you call it? Oh no, I can't remember. And then chat's like, baby food. And I'm like, oh yeah, baby food. That's what I was talking about. Like, I'm like a dementia patient on this stream. It's really frustrating. And then I went to dinner with a buddy of mine the other night, and I was doing it there too. I must have still, I think you're just describing ADHD to a degree. Yeah. But I went to dinner with a friend, and I couldn't come up with basic stuff. It felt, oh man, I felt so like debilitated, and it must just be the mental exhaustion of streaming. I need to test something. Oh yeah, that still works. Okay. I didn't see Crash Systems message come up there, and I thought something broke. Let's just check to see that YouTube is still quiet. Oh no, wait, we saw Lawn Dog. That's right. Okay, yeah. So all that stuff is still working. Good. Tired plus ADHD. I mean, as soon as I get alcohol in me, I think that negates the methylphenidate that I take. So that was out the window, and so it just was full on ADHD with the drugs probably still in my system. As someone who does have ADHD, well, I do too. I absolutely do. I spend an inexcusable amount of time looking up how to get the length of a string. The length of a string. Why? That's a very interesting fixation. I don't know where that would come out of. I have the unfortunate, what do you even call that? Ability, like being what is deemed a maker, and being able to do projects on stream. Hello equals 5 characters. Oh, the length of a string in like, yeah, as in a data type. That's tough. So unfortunately, I have the justification to start 10,000 projects a month, right? I keep starting projects, start a project. I don't have the advantage of having the freeness of Uo's lab. I think the genius of Uo's lab is that he does stuff just so haphazardly that he can jump from project to project to project. And it's very fun and clear when you can just go, I want to do this, I want to do that, I want to do this, I want to do that. And the variety keeps up, right? We try to do variety projects, but I keep coming up with the same stuff over and over again because I want to actually complete this stuff. These are very useful things, and they're very interesting things to build. I have to stifle the fire hose of ideas that comes out of the ADHD mind. I'm gonna get into this. I'm gonna do this now. I'm gonna look at this. I'm gonna do that. Blah 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 blah. This is a mausoleum that we're in right now, and it's a grave site. It's a testament to the sort of fire hose of ideas that churns through my brain on a regular basis. We've focused pretty hard on finishing things, but the ever-present Project Zilla is sitting behind me, and we will get to working on that. I keep saying that, and you guys may not see it, but the stuff that we've done in Node Red has been monumental in furthering Burn the Subs. Let me get the music out of here, and we'll get started. Of course, we're starting just at a time when lunch has pushed my glucose level to the point where I am extremely thirsty. It's one of the symptoms of a high blood glucose level, is you get kind of an insatiable thirst. And I am insatiably thirsty right now. I'm going to have to take a big swig of the seltzer water that I have, and we'll continue. Hold on one sec. Let me just put you guys here. Bother writes the sub in Sharpie. That's been suggested. That is actually not a new suggestion to me. Of me just writing names like on a board. Actually, that was the original idea behind Burn the Subs. I said, how can I do like a whiteboard where I have to go shake my ass in front of the camera and write down people's names? Because that was sort of the meta at the time on Twitch. It's gotten much worse, and then I don't know. Is there a meta right now? There might not be. They might have, because they relegated all the metas to their own channels, their own categories, and that's kind of helped the rest of us out. It's been kind of a good thing. So I don't know if there's still, but back then the meta was you have a Sharpie, and since your camera angle's so low to show off all of your TNA, you have the whiteboard low to the ground, and you go, oh, thanks for subbing. Let me go write your name on the board. You fart into the camera a lot. That was sort of the meta. And I was like, how can I do that in my own way, in Bother's way? And I said, well, that banana, the banana that chat could speak through, ended up getting the channel canceled, which would be good press. I could do something very similar. I have a laser. And so I got my big laser, and we did some tests with it, and that led to Burn the Subs, which is an automated board that burns the names of subscribers up onto itself. And I have two boards that represent something like 7,000 or 8,000 subscriber names. This one has taken us a while just because of the whole everything, just the whole whatever. Just my malaise, my depression about continually working on the project. I am very thankful that it was so successful in its previous forms. We needed a break, and so we've had a break, and we're sort of slowly getting back into working on it again. Yesterday, or last stream, we fixed my buddy's synthesizer. He once again plugged it into power backwards. Julian plugged in the 7805 powered device backwards. I don't know how he keeps doing this, but he keeps doing this. I mean, it's all well and good because these are easy fixes for me. I happen to have a bin full of exactly the 7805. I could have given him an upgraded 7805, but in terms of like the synthesizer stuff, it does not need 800 milliamps. It doesn't need, I think, 500 for these because they don't have an external heatsink. So 500 milliamps is plenty. Most of these synthesizers use under 100 because they're only pushing voltage levels around, right? So we didn't need to upgrade his voltage regulator, but I could have probably also put a diode in there, and the diode would, of course, limit current if he happened to plug it in backwards. But this is his DIY. He built the thing, so I don't want to do too much doctoring to it. I know I sure would have wanted to put a diode into it, but here we are. So this is symptomatic of, sounds like it needs a go, no-go. What is that? All I know is that if I put two diodes on the thing, I could protect this whole circuit. I think it only uses plus 12. This uses ground and plus 12. So if I fire a diode into the thing, it'll block the current when it goes in reverse. It would pay to design reverse polarity protection into these modules, but they maybe pays more not to. A couple shocky diodes are not going to break the bank. It's two parts on an otherwise whatever. Anyway, so we put a new 7805 in. This is indicative of a 7805 that's been plugged in backwards. This thing got negative 12 volts. On its from ground to power, it got negative 12 volts, and it went, I don't know what to do with that, and blew up. So you can see the die there. There's a little bit of evidence of a gold bonding wire, I think, but a little TR written on it. It's got an S, looking pretty charred. This thing blew up violently. Anyway, let's put the desk back into normal configuration where things aren't shaking all over the place, and we can work on, well, another thing that I'm kind of reluctant to work on. I'm currently falling down a rabbit hole of current shunts, sense amps, and ADCs. It's fun. So, you got your own definition of fun there, and I can respect that, but yeah, there's all kinds of stuff you can do on power supplies to protect them. All kind of stuff. All right, so get the camera back in order without disconnecting USB. I've got to be really careful not to do that because this camera will freeze if I bounce that USB wrong. And I've been meaning to 3D print or something. Change this over to USB-C, I guess, would be one strategy. There's just like a little board with that connector sticking out of it. And I think I'm not sure I have right angle ones, but I do have USB-C boards of all kinds. So one day I would like to do a repair on this and change it over to USB-C, and then I can drill a hole through the case and thread the whole hole, and then I can use my screw-in USB-C connectors. Those things are awesome. I know Reddit recently discovered those. They said, hey, haha, look at this. You can screw in a USB-C. Why would you ever want to do that? And I'm like, bitch, have you ever worked on production stuff? Like, if you want something to be plugged in and for, some drunk guy to not be able to stumble over it and disconnect your whole concert, you'll want screw connectors. Those things are built so that you could park a car on top of them and it won't disconnect. Metrology is my favorite electronics subject. Sensors of all kinds. Sensors are awesome. I love weird sensors. I really, really do. At some point, I will go to Pololu. No, who's the one that had them? Seed Studio, and I'll buy a bunch of their no contact, like respiration, no contact heartbeat sensor. This is a project. So my father works in clinical psychiatry. So it's like administering medications to patients that are overnight, or well, they're multiple overnights. They're troubled and he needs to put them on medication to make them right again, right? And so you put them on these powerful medications. That's a touchy subject because these people can sometimes just die on these medications. These are serious meds for serious needs, right? And so they have a nurse go through and tap on the window and wake these people up to make sure they're still breathing. If you can have a no contact respiration and like heart monitor, that would be a huge boon to their ability to make sure that people wake up the next day. They actually can get to a patient that's having trouble. But yeah, those Seed Studio, because that's something my dad has come to me before and been like, there has to be something that can address this, right? I'm like, Wi-Fi can detect respiration. I'm not sure. I mean, I'm not a medical company and I don't have a team of powerful lawyers, so I can't do that project for my dad. But these sensors came out in Seed Studio that do that stuff. So I want to buy some and point them at little old me. You guys can see how high my blood pressure is and how terrible my respiration and heart rate is. And we could play like a scary game or something. That would be great. But that's sensors. I love sensors. Make it 12 volt horsepower plus. What? Monitor board with an STM32. Takes 3 PC. Oh my God, that's a lot of data. Melting prong 12 volt. Okay, so thermocouple on the wires. Jeez. Okay, here's what we're doing today. So today, working with high voltage. I hate working with high voltage. I really do. I don't like it. It's scary. I'm wearing all this diabetes equipment that I don't want to blow up, but we got to do something exciting at least once. I really don't want to push my luck here. We've had a nice time streaming, right? I'm not willing to sort of bring that to an end as with myself. Big capacitors store a lot of energy, right? Big capacitors store a lot of energy, and I do not want to be cavalier around big caps. These are the size of shotgun shells. They store the energy of a shotgun blast. I don't want to be anywhere near that. Little capacitors popping off, that's funny, that's fun. This thing popping off is not going to be very fun. My ears will be ringing. So what we want to do is we want to make absolutely fucking sure that we are well within the voltages on the caps. We want to monitor the thermal imager to make sure that we don't overheat any of the caps, and I don't want to go anywhere near above the voltages that these things quote. Now, when we were looking at this whole system, we were like, hey, this works pretty good. What happens when we give it 24 volts? Well, it snaps off a little harder. There's an amount of resistance in all the wire on this thing. There's a certain number of turns. We can't control any of that stuff. What we can control is how many volts go through there. V is equal to IR, power is equal to PIV, I think it is. Penis in vagina, that's the wrong one. That's actually that's a filthy act. Wait, what is it? Power is equal to I squared something or other, whatever. All those basic basic electrical equations play in here. And so the one thing we can control is voltage. If we have enough of that voltage sitting around, that'll give us a significant punch. We don't need to be there for a very long time. So if I double these up, these are some of the only big capacitors that I have access to at the moment. I don't think I might have two. I I think I might have a couple 300 volts that might give us a big punch. And that was from the power supply project. So I need to go get the power supply project. Wait a minute. The memories are flooding back of the times that I've had big caps. We don't need it for very long though. That's the good part about this. We only need to punch it for like a millisecond in order to get that thing to move fast enough to throw one of these tiny little emotes at me. I'm making a 240 volt, 600 cc, 500 horsepower, 0 to 60 in 4.2 seconds Arduino blinker. Blanc. All right, let me go get those other caps because those are actually larger than these. Let's see if we can actually find them. This is I have to sort through my my bins over here. Here, let's new unique view of Father's shop. Hopefully without addressing label all over the place. Well, these are address labeled, but they're too small for you guys to read. So, and also you guys can't read. So, oh, here they are. They're right here. It's almost like I looked at this earlier and knew they were here. I promise you that I didn't. I only have two. I only have two. Oh, here's the third. Okay, 3 might do. We'll see. I'm not ordering caps. We're just using caps that I already have. Although this cap bank could also be, because this has 2 more inside of it. And it's got bleed resistors on it and everything. So, all right, let's see here. The robot, that is a plush robot from GCP Gray. That's the AI robot. And for his little AI video, he had those little robots to represent how AI trains and stuff like that. So these cute little robots explaining the downfall of mankind and the bullshit that we all got to deal with today. We didn't know back when that video was published how crappy this would be. Ah! Stop having ideas. You know what? I'm going to have a red sub alert on that. Let's put a red sub alert on that. Go over to here, and we're going to do, on a subscription, we will set off, copy this one, and we're going to make that red, and power on, color red, and then we do the same thing. We delay 2 seconds. Oops. Get a filter on it. And we go to bulb 2. Oops. Ah, cancel. I'm moving too quickly. Copy, paste. There you go. Oh, we still need the off node. This one goes away. And then for right now, we'll just put that directly off of subscription. So there we go. If somebody subs, I will get a red light alert over here. I also really need to get this working with the file server. If I can get this working with the file server, I can have it check the drive status and possibly set off some incredible alerts if the smart status drops. Good to know that it doesn't work. Incredible Mike, thank you for gifting a sub. What happened? Hold on. Let's put a thing in there. Okay, so that worked. Payload event type. This one is payload.event type redeem. Payload.event type, is it capital? Oh, yeah. Gift subscription. We need to capture a gift subscription. redeploy. Oh, do I have to redeploy when I activate that? Maybe, I don't know, we'll see. That's okay, so there's our chat, channel chat message. So I'm looking for a gift sub. Nobody is under any obligation to gift sub. I will capture that later if there's a gift sub. I mean, at least this is powerful enough that we can sit here and capture. Oh, you didn't have to do that, Akron Mike. That's don't do that again. Don't do that again. You're very nice to be able to do that. Channel chat notification. Channel chat notification. Subscribe gift. That is really eclectic. That's hard. I would not have been able to figure that one out. You aren't the boss of me. Listen here, you little shit. All right, let's add one equals subscribe gift. Done. And that's what a subscribe gift looks like, I guess. So I was looking at, again, Project Creep, right? I was looking around and somebody posted it to the main chat, right? No, or I found it. I think I found it on Reddit. A split flap display. I was thinking that we could make a big one that goes above the board, and I could have that point out these, gifters or subscribers. That would be a really cool thing to kind of come to life. And as somebody from Philadelphia, I am familiar with 30th Street Station. As somebody who grew up and was a teenager living in Philadelphia and the surrounding suburbs, I know what a split flap display is like. It's 30th Street Station, huge, cavernous train station, used to have a split flap. Split flap sounds really like a bad thing to say. It had a split flap main board. And so the whole thing every now and then would reconfigure. It was amazing. The sound when you're trying to do something delicate. I am barely holding on. I can barely keep my hands steady. And I'm attaching the motor wire to the pin of the BG array. And then suddenly, right behind me, I forgot to ask, how often does Gritty chase you? We stay away from Gritty. We give him plenty of room, do what he needs to do. All right, so we should now have, considering, I don't know, lowercase subscription. I don't know if they'll do, if the event is subscription, just a regular one. I'll keep an eye out for it. But we should have the light on the desk will flash red at me. Nothing crazy complicated, but again, these are the seeds of what will power the shop in the future. So making that split flap display as a 3D printed object is going to be an absolute beast. It's going to be a lot of 3D printing. I'm going to need to buy filament specifically for this project, but it'll also be really cool. And apparently, I've already got the white PETG that I can use, so the split flaps will be black up until the top layer that's white, and then it'll have the lettering on it. I think that's going to be really cool. I think that'll be something that we should definitely dedicate ourselves to, and it's going to be a major project for this stream. It'll also be a project where it's literally just me 3D printing something, and the parts are stuff that I might still have. I might have to buy new. I hate to buy new, but I know I've got some of those little motors that all these 3D printing projects use the same motor and controller. So no, I don't have ABS. Plus, I'm very comfortable printing PETG, so I'll keep it within my own means. Although with the cheaper plastic, it'll sound more like the real board, which really does make this wonderful chittering noise as it flips through stuff. But I think the ability to put 12 to 14 characters above the board and be like, subscription, it'll say like Madam You, in this big production, that'll be really cool. I think that'll be a very, very cool thing. So we should do that at some point. The files were Fusion 360 files. Fusion 360 was down yesterday. Whoops-a-daisy. Okay, so instead of getting these out, these are 300 microfarads. I have 1,500 microfarads. So 4,500 microfarads sitting right in front of us. Do we need all of these? No. We're going to start with all of these, though. These are 200 volts still. 200 volts. this power supply is for Nixie tubes. Nixie tubes are an old type of display, very popular, I guess, in Russia, because all the stuff for them is in Cyrillic. Ukraine actually made vacuum tubes for a while, so I don't know if it's necessarily Russian or what, but Nixie tubes are basically a bunch of neon lamps that are shoved in to each other and in sort of like a layered fashion. And so what you have is, my head injury. This is like way too bright. Wait, what's going on here? You're not allowed to move. This is way too bright. How'd you get so bright? I must have hit this. There we go. So a Nixie tube, it's a vacuum tube. In it, I mean, it's a vacuum tube, but it's basically a neon lamp. And if you know anything about neon lamps, it's basically neon lamps are two posts with an anode and a cathode, and one of them glows orange. So this thing right here is a Nixie tube, but this is a slightly more rare Nixie tube. The 0185 is actually meant for like this one, I think, a multimeter, because you've got volts, you've got amps, you've got ohms. All of those are plates that are layered on top of one another. And when they're activated, they glow with this wonderful warm orange glow, and you can see the full letter even though it's being obscured by its neighbors above it. So that's basically all this thing does, is these things glow. And so they've infected the maker scene and the DIY scene in producing every single kind of clock you could ever imagine. What do you mean broken? Broken. Why are you broken? You don't seem broken to me. You seem just fine. Now it's probably broken. But you can see here that there's layers of letters, of numbers rather. Numbers layered on top of one another. And one of the cool things that these do, one of the cool things that the Nixie tubes do, when you see them actually counting, you know, people have made like graphics of Nixie tubes and stuff like that. They make clocks. Clocks don't move all that fast. If you've got something like a decade counter, which is a piece of lab equipment that measures how many pulses you get or any of a number of things, and you watch that thing count, the numbers are going like this. They're sort of like pushing up from behind because all that 1 through 8 is stacked. It's kind of cool to watch. So these things need to be driven with like a high voltage AC or DC current. I think typically they're DC. And because they're really super popular with the maker scene, you can find all kinds of power supply boards for them. And you can also get Russian TTL level drivers for them. So the Russian TTL level driver is this 8910, 897. I think it's K155, and then characters that we can't type on our keyboards without using alt coding. These little ceramic drivers will actually work with the 60 volts, and they'll switch one of their outputs when given a binary number in TTL style. So you'll give it the number, and then it'll switch. And then you can also buy power supplies that are just little boards that take in 5 volts. 5 volts in, ground, and we're going to have to see what voltage they produce and make sure that they don't go over voltage. K155ID1? Yeah. So that chip is really helpful when you're building something with displays. So this right here is a high voltage from nixieclock.org. Oh, I just bought it on Amazon. It's a high voltage driver. Problem with this one is we've got shut down V in. That's V out. Oh, I see. I can adjust it. Okay, that might be helpful. Well, the problem is this thing, 12 to 24 DC in, 85 to 235 out. You can use Nixie tubes in Fallout 4. Yeah, they're like the size of a table. They're huge. I wonder if they do the counting effect of moving horizontally. So this one is not going to work. This is 85 volts. Moreover, we need to do a little bit of legwork here, looking up the MOSFETs that we're going to use. my idea for this was that we would have our high voltage power supply and a huge resistor on one side of these sort of motor cutoff MOSFETs. So this would fully disconnect, right? I don't know if this is a full disconnect. It's as much of a disconnect as we want, I guess. It'll cut off quite a bit. So we basically have a big resistor as a current limiting resistor, because these things will take everything at all at once and it'll overload the power supply. So what we want to do is we want to have our power supply, big current limiting resistor, and then the power supply will shove all that current into the resistor and a little bit will trickle through, and that trickle will charge up our big caps. And once all that's charged up, we turn this off. When we turn this off, we're cutting off the supply. And so now it's isolated behind two MOSFETs, hopefully. And so with that power supply isolated, we can then set off the second one, the second bank of these things, and it'll connect to the coil, rapidly discharge, everybody blows up, and then we all go home injured. Everybody blows up, and then we can cut it off again and charge it up again. That's the idea anyway. I don't know how isolated things will be, though. I see. I and D, you just sub in. So these boards, I don't know if they're connected the way that I want them to be. Really, technically, I'd want Q1 and Q2 to fully cut off the output, but these share V in and V out, really? V in minus and V out minus. What? V in and V out plus is connected. And then for some reason, we've got to connect the minuses, we have to go through two MOSFETs. E4184. E4184. That's our chip. Oh, and that's our module. 5 to 36 volts. Okay, these won't work. Oh, this is different. This is a different setup. This is a different board entirely. This isn't what I ordered. These are the ones I ordered. 5 to 36, 15 amp max, 400 watt, dual high power MOSFET, trigger switch drive module, PWM adjustment, electronic switch control, border mode, speed control, lamp brightness control. Whew. What are you talking about? Pull up to the window. What? 5 to 36, trigger source, digital high low, blah, 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 continuous current, 5 amps. Where is my circuit? What do they expect me to? So the pluses would be connected, and then the minuses go through two MOSFETs? That's a little weird. Oh, you found like a full data sheet for it? You guys do not need to be doing all this work. Yeah, but I don't want you guys to influence the pace or the narrative of the stream for me. Oh, these are the Nixie tube drivers. Yeah, pretty cool. You basically give it a ones and zeros, and then the output. Yeah, you give it BCD. There you go, binary coded decimal, and then it does the job of flipping the triacs or whatever. BCD decimal decoder designed to drive gas-filled Nixie tubes. The device is also capable of driving other types of low current amps and relays. An over-range decoding feature provides that if binary numbers between 10 and 15 are applied to the input, the least significant bit will be decoded on the output. So that's so you can chain them together and you can have larger numbers go through it if you want. 10 through 15, all the outputs are off, therefore blah, blah, blah. Yeah, anyway, so that's, yeah, pretty cool stuff. All right, anyway. So the circuit on this thing, why it the way it is? I see no issue with the soldering. Each component is correctly soldered onto the correct place. Anybody reverse engineer it? No? All right. I'm going to have to figure out what the circuit looks like, but these FETs are out, so we need to find something else to do the switching. That's always fun. I was hoping these boards would be able to do the switching, but they only go up to 35, 36 volts. I have a feeling that these Dixie tube power supplies are less than 36. We can try charging the cap bank with 32 volts. We can do that with the power supply that I have. My power supply goes up to 50. So, I mean, 32 will be very easy for us to do. Our best results were with something around 34 volts, right? We did 24, I thought, and that gave it a pretty good punch. So if we hit it with 30 volts, that'll be a lot of energy, and maybe that'll do it for us, which means these 200-volt capacitors are totally unnecessary. But we need big caps, and they're big caps. I think the only other ones that I have are the super caps over there, and those are 5 volts. So I'm not going above 5 volts on those. Let's see. We did charge that big bank of capacitors with 5 volts, and I soldered one tiny little measly 3mm LED to it, and it lit the LED for like a month and a half, 2 months. It was crazy. Okay, so this circuit cuts off the minus lead. I don't know if I like that. I kind of wanted it to do a full cutoff. If we use a relay, that's going to make sparking, and sparking is going to eventually wear down all the contacts of these things. You know, doing big motor stuff with relays is fine, but when you do it, if you've got something like a refrigerator compressor on your relay circuit, it can spark and then wear through the relay in an incredibly short amount of time, like a month. I think it was a little longer than a month, but that's what was powering my fridge, and it just wasn't working out. So I spec'd out and bought a solid state relay for that, and now it's lasted forever. Although I still need to get that back up and running. Okay, so 35 volts I was hoping we'd get something with a bit more voltage on it, because this thing goes up to 100. But if our MOSFETs aren't going to work, they're not going to work. Let's look for other MOSFETs. Let's see if I can find other MOSFETs. I have some stashed away, so there's a possibility that I have sufficiently high voltage FETs sitting around. Might be in here. Let's just take a quick look. I know all those are 7805s. Oh, you know what I had? I had some through-hole 6-pin jobbies. Yeah, these right here. I think these are triacs, though, so they might be AC only. Googling how a solid-state relay works. It's a bunch of MOSFETs. It's just a slightly more complicated MOSFET setup, or triac if it's AC. All right, these I bought to control EL lighting, so I don't know if they're going to be suitable for this. These are an old purchase for a big project that never got underway. Mach 3063, MOC 3063. Stupid small keyboard. They lie about the ratings. Solid state relay is a triac with an opto-isolator triac. So basically a triac Darlington with an optocoupler. I think they're a little bit more complicated than that, but not by much. That's essentially how they're going to be working for the most part. What is this view? Oh, it's Mauser. Light on. Opto-isolator 5 kilovolt triac. So this is more than likely, this is meant for AC. Isolation, 6-pin dip, high repetitive peak off-state voltage VDRM, minimum 600 volt, high critical raise of off-sign, dip package, wide lead spacing, tape and reel, etc., etc. So we've got an opto-isolated triac, but triac is for AC, right? Yeah, current limiting and snubber type stuff for like if you connect it to a motor. Are you thinking of a motor driver? I mean, what I'm thinking of is a way to isolate our high voltage. So this isn't really what we're looking for. Yeah, this would be AC stuff. And I guess this you'd be flipping another thing with. So we need, I mean, what we need is a MOSFET. A triac is meant for AC. And then you have like 0 crossing triacs that cut off at specific times so that your switching is clean. But these were for a different project. The EL is an AC device. And so I was going to use those to flip on the different strands of EL on like a thing. So that's not it. That's not what we're looking for. There were a bunch of MOSFETs, I think, that I ordered. These are all 7805s. Yeah. These are all voltage regulators up here. So it's in a different bin. I think they ended up in a different bin. How high voltage? I'm hoping we can get to like 100. That'll make this sufficiently scary and unsafe. I don't know what else is going to blow up when I get to 100 volts, but we'll find out. What's in here? No, hold on. I got a couple more bins to go through. Couple more bins to go through. Yeah, here's some FETs that showed up randomly that I ordered a while back. $100 volts fast switching. Now that's cool. What do you have that's 100 volts? the unfortunate nature of my stream is that I'm not going to find out if the modifications that we did to the light over here will work until like next time, because we've already gotten the day's subs. Oh yeah, fuel injectors. There was a time when I would probably have had a fuel injector transformer available. Yeah, exactly. Well, for this, so the idea for this, tip 122s, this is a fairly famous, well, maybe for me, FET. What is that? That was Incredimike gifting a sub to rounding error and nothing happened. Did you guys see? Did this do anything? Let's check in on, oh, but I turned off the debug. Dumb. Thank you, Incredimike. That did not turn on. So if I inject into here, oh, I'm sorry, Incredimike. Now it'll work. Yeah, if I inject into there, this lights up. There. So now I am fully aware whether or not somebody subs, theoretically, unless subscription is capitalized. But I don't think it is. Ah, it sucked. One little wire and it would have worked. All right, I'm confident in that. That'll be fine. Tip 122. Let's see what the ratings are on that thing. I used to see a lot of these. Tip 122 datasheet. Get out of here. Just give me the datasheet. There we go. Low collector emitter saturation, complementary NPN-PNP transistor. So this is a Darlington array. A Darlington array is just a fancy way to say that they have a small transistor triggering a large transistor, because you've got to get those electric fields to move in order to create a pathway with the holes and electrons from the collector to the emitter, right? That's the main switching current. Is going to go from collector to emitter, emitter to collector, either way. It's going to flow in a particular direction. So in order to get it to flow in that particular direction, you have a big transistor, and you want to bias that big transistor, but that big transistor requires more biasing than you are capable of supplying. So what you do is you supply your eeny weeny little tiny lower current transistor. You hook them up to one another, and so you've got your small domino hitting your big domino. That's basically what it is. That you call a Darlington array. So even if you're building that on a board, oh, there's a Darlington right there, or you have a device that has all that stuff in it already, which is what this is. This apparently has a flyback diode, although I'd probably suggest putting a flyback diode on anyway. What are our specs, though? The TIP122 is probably a little higher current, isn't it? Let's go down and see 100 volts, so 80 to 100 volts. So if we go to 80 volts, if we do 80 volts, we can use the TIP 122. And that way it is in, wait a minute, the TIP 122 is 100. So we can get close to 100 with this for the collector base. Wait, collector, base, collector, emitter. Okay. So this works with 100 volts just fine. Is it going to see more than 5 amps? No, because we are not going to allow it to be 5 amps. We are going to slowly charge this like as if it was like a camcorder or a camera battery. So we can use the adjustable power supply that I put away. Damn it. Get the adjustable power supply back out. We'll use the adjustable power supply. We'll give it a big old stinky resistor so that we're not high current. And we'll let that slowly charge it up. What? What is that, giant? Somebody at a Discord I'm at is I'm having fun with a 100 volt, 6,000 watt PSU. I don't need it, but I want it. Working engineer at a German car manufacturer. Oh my God. Wait, let's take a look at this thing. German car manufacturer, and this is their equipment. I guess that's reasonable. They got their B&O precision and then isolation routing boxes. That's crazy. And so this is the power supply. Holy shit. What the hell? That thing's huge. Huge. Current monitor. Big. Pies. That thing makes pie? It's got everything. Look at the terminals on that thing. Holy shit. Yeah, this is one of those things where you like power down the lab and then work on this stuff, walk away and then power it back up. Yeah, you can charge your phone on it. Are you sure this has enough to charge my phone? That is wild. That's some crazy equipment. Oh, I like the eyelets on it to move it around. Cool stuff. Man, I'm glad we got the TIP 122, huh? So NPN, and we can switch 100 volts with it. Do I do one on each side in order to cut it off, or do I just do input and output? Like, do I just cut off the plus side? These things cut off twice. These things. That's a weird circuit. How are they connected? Let's see. Yeah, the collectors are those top things. They're just limiting. That one connects it to minus. So V in minus connected to the top of this thing. Oh, does it go over to the other one from there? And then it goes to the V out minus. So yeah, it's got to go through 2 FETs in order to turn on and off. Why would you do that way? Wouldn't you want one on positive and the other on negative? That's strange. Guys, it's a live wire utility. Yeah, like the people that climb on the wires. There are those videos out of China where the guy's climbing on this wire and he's like, it's a live wire and he's just got like a rope to keep him safe. And he's like thousands of feet in the air. And it's snowing. It's like, what the hell is going on? It's absolutely ridiculous. All right, so this thing is out. We're not using that. That means that this stuff is out because we're not going to use one of these. Could it be a FET on each side of the board so they're actually in parallel? No, because look, that's how, that would be the logical thing, right? You would think like, hey, cut off the thing completely, but V in plus and V out plus are connected to each other. So it's like weird. The D4184 is a low side switch. They're both D4184s. Are they in parallel? They could be. Let's see, that's triggering that and the thing there, and then this one connects over to the other one. Yeah, I guess they're in parallel. Water scares me more than electricity, not me. I like water. What do you find? Use dual MOSFET switch schematic to find the actual thing. Ah, why is it? Open a new window. No, not in the same tab. Oh my God. Okay, over here, 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 over here. So this is, looks like an Eagle schematic. So it is just in parallel. So they put these in parallel, which is a strange way to do this. Why is that like this? E out. This is wrong. What's going on here? WordPress is the worst URLs. This one isn't bad. Yeah, and I guess following the dot schema that works, but it's like, where's it going? It's not going down to this ground unless they did something weird. It really V in minus and V out minus are connected to one another. Wait, no, they aren't. It's V out plus and V in plus. Oh, I see. Okay, so they could have rearranged these. It's a little confusing. This, I would put this up one just to make sure that it crosses here, and then it's communicated properly. V out, V in minus is ground, and that goes to the rest of the circuit's grounds. And then V out minus goes, oh, crosses over this. This is bad, and goes to both FETs where it's switched to ground. Now the FETs want a particular flow of electrons across them. Would it be bad for us to put an NPN on the top of the bottom? TIP 122. Let's just circuit. We'll get some advice here on the specific FET that we're using. Darlington. 100-watt powerful amplifier. I don't think that's what we're doing. We're switching with the Darlington array. We're not amplifying with one. NPN transistor, 5 amps, 100 volts. Oh my God, it's a whole cascade. So we can cut off just the positive, I guess. There's justification for cutting off the whole thing. I don't know. Cutting off the whole thing means that whatever gets to that ground connection won't get back to our ESP8266 and our other sensitive electronics. So we're going to set this guy to 100 volts. We're going to have this. Well, I mean, this could activate it even. We could turn it on and off. We're not doing anything with these unless we cut off power to something, but I don't think we need to do that. We need a little bit more space to build our circuit. I don't know if breadboarding is kosher for 100 volts, but we're gonna do it. We're gonna do it. Let me find a breadboard. Breadboard! Hark! Where are you? Where are my breadboards? I think they're down here. Is a bother accidentally building a railgun? It is very much a component of a railgun, and we could probably look up a railgun to see what their circuits are. I'm sure they're probably better laid out than anything we would come up with on the fly in here. You need screw terminals? I got screw terminals. I mean, I don't think we're going to be pushing 5 amps with this thing. Other locations, here's a good one. This one will do. Just our simple one-row breadboard. That gives us a little bit of extra room and some rails if we really need them. Power is going in through USB. Isolating from the computer would probably be nice to do, but I think we'll do all right. And then here is the trick with these guys. These are high-power devices, right? We're going to put them in the breadboard, although we really should probably just come up with our own circuit for these that's like isolated, possibly has a heatsink on it. For our initial test, I'm going to use the breadboard, and I'm not going to like it. In order to put these on the breadboard, we can do a very special thing, and that is to twist the legs of the transistor. This is a trick that I guess we got through the Discord. It's something somebody shared a bunch of tricks with electronics, and this is one of them. So what I'm going to do, in the past, what I would have done is soldered this onto a header, which might be the way to go, but I want to try this trick. So grab on and just twist 90 degrees. Grab on, twist 90 degrees. Grab on, twist 90. So now these three blades coming out of the bottom of this are in alignment with the clips of the breadboard. Probably a better thing to do with like a 7805 than a tip 122 that's going to work at 100 volts. But because of the way that the clips are oriented inside of this board, you've got these horizontal clips, and so now this will very easily just fit right in. The whole 0.1 inch space standard. Whoever decided back in like whenever we invented everything, because America, whenever America decided to invent everything cool, really should have thought about using the metric system. I know back then a breadboard was a literal cutting board that you would screw stuff onto and build your electronic circuits on. But whoever decided to manufacture these things and, you know, make that standard that influences all of electronics, it would have been nice if it was metric. We're supposed to be ahead of the curve here, guys. So can I have a tip 122 on the positive and the negative? I think I can only have it on the negative, right? What is it? Tip 122 is NPN, right? Tip 122 NPN. So NPN switching circuit. Yeah, so NPN, we are switching ground to our load. I'm not too keen on that, though. Can I do... Tip 122 is just what we were able to find. So like that. And then we've got this going in. So if I had a resistor and then an HV, this is way too thin. Hold on. Yeah, you didn't know that? The sub badges are literal photos that I took using the microscope of those special character display Nixie tubes. There's not enough of them though. I need to overhaul. I need to overhaul graphics on this stream. And I feel bad because I haven't done it. That'll be plenty thick. Let's get a little closer. Boop. And then so we've got ESP. The graphics are getting a little stale in my mind. $1K going into our NPN. This is a little direct. This is a little bit too direct, but let's just see. So if I do, where's the arrow on NPN? Going to the lower load. So we have this here with an arrow, and then we have this, which goes to, let's move this down a little bit. An undetermined value resistor, and that goes to 100 volts. So we're switching through this thing. So this would then go to our bank of caps. It's gonna look like a pretty sad bank of caps, but whatever. And then all these, I suppose, will be connected to ground. So that'll charge them up. Then when I want to set them off, I can turn that one off, and I'll have another one here. that will go to the coil and the flyback diode. And that'll launch the emote. You need to get the base voltage above the emitter to put it into conduction, which is going to be a problem when it's a high side switch. Base voltage above the emitter. So it's not going to like being a high side switch. I don't think I have PNP Darlingtons. We 125, 126, and 127. So here's the deal. I don't want that power supply, the 100-volt power supply, to be connected to everybody. I mean, I guess it'll be okay because of the current limiting resistor, right? The current limiting resistor, I suppose, will be doing that job. So instead of having this here, we would have volts there, and then we would be giving this ground in order to charge it. Oops, wait, I can go up into that. Yeah, so we do it here, this. No, that's the wrong one. That's the wrong way. A little more confusing to look at, but it'd be like this. Let's clean this up. Good old napkin drawings, right? How's the song that I hate from that mix stuck in my head? I guess this could have been above. It could have been facing upwards, and then I could have gone up and around. But we're stuck with what we got. All right, so it's from here into this, that, arrow. Ugh. I need more space down here is what I need. Totally killed my 1K. There we go. Is there a way to have a PNP connected to the 100-volt supply and drive the base of the NPN? Surely that's a thing. I would need that PNP, which I don't have. That's what I don't have. So here's the idea. Isolators over here would probably be nice, but I guess we're going to risk the ESP. I could use the power supply over here in order to power everybody. our input is 12 to something or other. So we've got 12 volts on this power supply. I guess we're just going to have to enable it at all times. Well, we could also go out to the 1K again. We'll have to look up the power supply. So yeah, our sequence of events: enable the power supply, turn on the first tip 122. That is, well, actually, we could make that a smaller transistor even, depending on how much current we're actually running through this thing. Although it still needs to be compatible with 100 volts, so we will probably keep the tip 122. You can high side drive the solenoid. The second one has to be on the low side. The more potential here is what we're getting at. There's a higher potential here than ground, and so that'll help keep this thing activated or deactivated. We won't be in kind of a weird state where it doesn't have that potential across it, which this will have the potential across it all the way up until it switches, and then when it lets go, we're going to have a small loop here that will be the reverse current loop. So it's going to go through that way, and that will protect our tip 122 here from any shenanigans that might occur. So 100 volts, little tiny trickle feed of 100 volts gets in here, charges up the capacitor. You aren't getting what I'm saying. The second switch has to be on the low side. Why? Wait, what are you talking about? The low side of the caps. Is that what you mean? Yeah, because we don't have a loop. Where's our loop? Well, because this is connected to ground. Oh, that's connected to ground. Wait a minute. Yeah. Okay. There's logic issues. All right, let me make mistakes, chat. Let me make mistakes, please. Allow me that luxury. I'll redraw that. So we're doing low side switching again over here. So that's going to have a transistor here, and this is going to connect to the coil. So my whole drawing falls apart. I really liked what that coil looked like, though. So I guess then these two get cut off and they get their own. But then I would need so wait a minute. It wouldn't make sense to have this here because I still need to have a circuit loop. So if I charge these, I can then connect this at the same time. That doesn't make any sense. Unless the transistor's here going this way. Arrow here. That puts this potential higher than this one. And our loop is from high to low that way when we trigger it. So we allow current to flow this way, which is a trickle feed. It can't go through this part of the loop because the other transistor is cutting it off. This is at a high potential, so there's lots of pluses up here, which means our collector is at a higher potential than our emitter. And when this thing comes along, a little tiny bit of current goes through the Darlington, and we get, boom, 5 amps through that at 100 volts. So I think this makes sense now. You guys can chime in. I'll allow critique of your perfect streamer's perfect circuit if you guys believe that this will work properly. Because I think in my head, this is making sense now. I just needed a little bit to think it through and a couple course corrections along the way. Thank you. That way I can disable the 100 volts so that we're not always charging these caps up. It's nice not to have fully charged 200-volt caps sitting around on your bench. It's, you know, maybe it's a minimum requirement of mine, but it's something that I like to watch out for, so that I don't accidentally put my arm across it. When I was doing audio circuits, like testing audio routers, we had these rack mount cases, but they weren't complete yet, right? They didn't have all the accoutrements. They didn't have the ears for the rack mount, and they didn't have tops on them, because they were constantly coming in and reprogramming all the microcontrollers because they were still getting things right. And so what we had to do was plug in these 1/4 inch plugs in the back, balanced 1/4 inch plugs into the back of the thing. And this used a separate power supply. So there was all of the driving circuit, front and back panel circuits, and then this big power supply. It was like a Jameco power supply that they bought. Thing about these power supply boards is that, well, they have big switching FETs on them, right? Big old switching FETs doing all kinds of weird jobs. These odd jobs that these things do, the tab of the FET can represent one of the voltage legs, whether it's input, output, ground. Typically, a heatsink inside of a power supply cannot be trusted to be ground. And so I'm sitting there plugging things in, and the case of the thing is ground. This was sitting at a cool 70 volts, and I was reaching like this, and I felt a very, very strong buzz in my arm. From then on, they came up with putting like a Mylar sheet over the power supply during testing, but I almost got a settlement out of that. If it had done any damage, I would have had a settlement on my hands. All right, so this is the idea. We have an enable pin that I don't know if the ESP can drive. We need to look up the specs of our PSU. We'll look up the specs of the PSU to see if the ESP, with its pithy little 3-volt system, can actually activate the power supply. That way, no licking to check if it's charged. Yeah. I put a bunch of 1980s LEDs across everything to see whether or not they exploded. I got zapped by a heatsink once. The sticker said the heatsink is hot. I assumed it meant temperature. It did not. Oh my God. I had those Vicor power supplies one time running my gaming computer without the fan going. And boy, howdy, did they get hot. I was like, I smell something like cooking, or I smell like that smell of heat. It's like assembly oil getting hot. It makes my hair stand on end, right? And it turned out that in transport, something had stalled my fan. I was like, oh God, and quickly got it working again and cooling itself off. Those modules are crazy. They create a lot of heat. They've got a lot of MOSFETs in them. All right, so simple idea. My big problem with this is that we're not like really fully isolating this stuff out. We've also got the high side constantly connected. That's just a safety thing for me, but with the enable pin of the PSU, we could turn this off, and then the only power is the stuff that's stored in these. It wouldn't be that big of a deal to drop the hammer on this and have the current running directly out of this, because this thing will limit it'll trickle feed our current. So it should be okay. The smell that smells, the smelly smell. Yeah, it's a very specific kind of smell of things heating up too much. This is not what I would do for a few reasons, but I'm going to let you. You're not letting me do anything. Let's get that straight. I'm doing this in my own volition. But the reason that I'm doing it this way is that I can turn off the 100-volt feed and then just have all the power sitting on these caps. Those will discharge, and then it'll stay discharged until we have a new thing that needs to be done. So we need to also put from here to here. Let's just do a voltmeter. That's where we'll observe stuff happening, is on that line. So let's look up this power supply board. Let's look it up. And of course, we're going to be putting it on the breadboard. This is like 100 volts and like a lot of amps, so stuff's not going to go. Son of a bitch. Cheesy Popcorn, thank you for testing our devices. Cheesy Popcorn's been subbed for 6 months with a Prime. Hell yeah, brother. So much unlike my LED turns on, Jeff Bezos has a little LED on his console that turns on, or rather it turns off when you sub to my channel, and that LED represents $5 going directly into his pocket. So you just walked up to Bezos and slapped the burger right out of his mouth, and I appreciate you for that. That characteristic smell, no clue what it is, but it can't be good for you, probably arsenic. I think it's assembly oil heating up. I think that's what we're smelling. Yeah, he's pissed. Bezos is mad. His little red head is like just about to pop like a pimple. Okay, so we were gonna look at what just happened. We have chat message, channel chat notification, subscribe gift to Incredimike. Oh, did I turn off the debug? I'm dumb. Why did I turn that off? Oh, how dumb am I? Ugh. Is the teeter operational? No, we don't have a teeter. Yeeter. Oh yeah, yeeter. Not operational. No. I mean, I think it's still hooked up, so the ESP is going to want to kick every time. It's not plugged in, but if I plugged this in right now, it would still be able to like trigger the solenoid board. But we're redoing some things here. The epoxy closest to the heating wire. That would make sense. We'll get there. Hold on. Let's get to doing this stuff. Oh God, where did the day go? How come I'm like out of time? We've done tons of stuff today. We'll be all right. We can go a little later today. Need those big pliers again. I'm gonna do the twist trick with all of these. Once it gets a care on it, the rest is insulated. Oh, it's Char, yeah. Sorry. Once it gets a character on it, what are you talking about? That's not the right type of data. So that's our switched output with a merciful span, and it's got the big diode on it. I don't know where I got these from, but these are really good diodes for motors. Darn it, I can't believe I missed Cheesy Popcorn's sub. That's so dumb. This debug's staying on. I don't know who else is going to sub, and gift subs don't count. I'm trying to catch specifically a subscription so that I know what the text is in the field. I could look it up too, but I don't feel like doing that. Learned about flyback diodes from the Yeeter stream, and it turns out I needed them for a mist coolant solenoid on my CNC. I'm telling you, man, flyback diodes are so important. I don't know why. I don't know how there is the capacity for somebody to learn about such a thing. Crash Systems. Oh, that's very nice of you. You initiated a subtrain. Thank you, Crash Systems. That's a good Twitch name. Flybacks will save your transistors. Yeah, I'm surprised that your misting system hasn't done something bad. Sometimes the flybacks can be built into stuff to just kind of like protect things, because I guess it's such a common thing. Channel hype train begin. Channel hype train in progress. Chat notification. Subscribe. Really? Okay, I'm fully confident now. I just double check. Subscribe. Yeah, there we go. Fully confident that we've got all the right data now. The hype train thing, I could make like a confetti thing that does a hype train. Every time there's a hype train, poof. I don't want to clean up confetti though. I don't trust my MOSFET built-in flybacks. I always add some extra ones. Yeah, it's a good thing. The fridge, my Arduino controlled refrigerator, the Ferment track system, when I use it as a regular refrigerator, it was just chewing through relay boards. Like every 6 months, it would kill a relay board. I was like, what is doing this? It's partially because I didn't have flybacks. I didn't know what to do with AC and flybacks, so instead I found a solid state relay board. And now it just permanently works. I got to get that Ferment track working again. I got to start up whatever the hell this thing is. Like Node-RED actually runs as an application on my server, my TrueNAS server. But I need to make whatever the little like virtual machine is that'll run what you call it. That will run like a Pi that I can do or whatever. Mead-RED. All right, I don't need anything else from chat right now. And actually, I could have put through, I think I can do fake subscriptions through Twitch. I think I can do that to test the API. All right, don't need that, not using AC. I've got 100 volts, 5 amps. These will do nicely. The only other thing that we need to look up is the power supply. The power supply comes from, well, let's a Nixie power supply version 1.1.0. Underscore final underscore this one. Is this the right thing? Yes. Yes, it is. (10 to 24 volts in). Jeez. 45 to 95 milliamps. We are still going to need to have, do we really need a current limiting resistor? We probably do. Oh, Magic Eye too. Shutdown, input current, 2 milliamps, input voltage, 1.2 volts. Okay, so we're good to control this directly. I may want to put in a current limiting resistor just to be nice, just so I don't blow everybody up. That's just the 1 kilo ohm resistor. Always on, off with shutdown. MCU control. Shutdown high is equal to off, low is equal to on. Recommended input capacitor if the module is located far from power. Module will generate heat. Be sure the board is well heat dissipated. Voltage increasing to the right. How much to this thing? I mean, it's a nice little board. This is how to install wires. They don't expect the best and the brightest to be using this thing. 22 to 16 AWD, rather, recommended. Okay, no input reverse polarity protection is required. Ground or float shutdown to enable switcher. Must be tied to V-in to turn off switcher. What is switcher? Miniature step-up DC-DC with high efficiency and low heat. Operating from 12 to 24. Set by a precise potentiometer. Designed for Nixie, VFT, Magic Eye. Shutdown modes are controlled via shutdown logic input. PCB terminals and pin headers are optional. Okay, cool. So that's the deal with this thing. This thing is only providing like 95 milliamps at the most, with V-in is equal to 12. V-out is equal to less than 200. So 55 to 90 milliamps. Charging up a big bank of capacitors. All right, well, let's get this built. So high voltage output is over here. This is, wait, what is that? They used a fancy font on this and it's kind of annoying. Okay, ground and V out are over here. And we can actually tune this. Let's, oh, this is going to, sockets. That doesn't help. Unless I'm just hooking it up to this. I don't know if this load is high Z or not. We can tune it up to 100 volts using this thing. So minus terminal, this one's the plus terminal. It's got washers on the back of this. This is an Amazon purchase, so I do not know if I trust this. I don't know if I really trust it that much. Seems a bit like a death trap. We'll see. Most of the circuit is pretty straightforward. Although it would have been nice to have Darlingtons on the on the positives as well, so I could fully isolate, but it seems like it'll be okay with it, sort of. Yeah, I suppose so. So V in, this one is shut down. So let's put this all the way at one end. Oh, come on. There's always one of the little pins that fights you. Jeez. Just slightly out of alignment, and so it's like, no, I won't let you plug in. Why do you hate me? Ow. Jeez, it hurt. There's a problem with the circuit. What is the problem with the circuit? What you got? What's wrong with this? The Darlingtons are set off by... let's see. Yeah, it's like... Vector, emitter, saturation, 2 volts. 2.5 base to emitter. Why would that backfeed all the voltage? These are NPN, so it's, what is it? Current goes this way. Whereas with a PNP, it would be going the other way. It would be going out to ground. Hold on, let's double check our circuits here. What do I not care what AI has to tell me about that? Switching. Get a little bit of an idea of what's going to go on here. 0 volts is on, so a little bit of that 12 volts is going to come through. 5 volts is equal to off, so when it's at 5 volts, this cuts. And we're an NPN Darlington. Well, I don't want to blow up my ESP. I don't want to blow up my ESP. So this one's PNP. PNP, the current VEB, it feeds back into this stuff. But NPN, you send out current and it goes to ground. Like this. So I don't know if I see that happening in this circuit. Because we have high potential, low potential. And then we send current in this way. Where's it going? That's a question there. It can't go if we send it in that way. It'd be going back into here, which doesn't make any sense. There are base resistors inside the TIP 122. Well, hold on, I'm having trouble actualizing this circuit. So I send current in this way, and it gets up through these. But how does that find its way back to here? Through the voltage meter? I don't think that would be the way. Because it certainly doesn't go through the loop like that. Send out current, goes up through there. What does my loop look like? It looks like nothing at all, nothing at all, nothing at all. Well, if there's super duper low potential here because we've had a big discharge going around this way, but initially in order to set it off, I need to have something go in this way and go through the transistor. And I guess it doesn't go through the transistor like that. So again, that wouldn't work. Well, how the hell does it work? I want to be able to cut off. All right, let's just look it up. Not a lot of forums are going to recommend to you ways to play with high voltage. Collector and emitter connect plus or 0. So if I move this to the positive side, like it was before, to here, and I keep the potentials running in the direction that the transistor is going to be happy with. So I keep it, well, I'd have to do it the opposite way. Like that. And then this is still connected to ground. And so our circuit loop is through the transistor, through the caps to ground. And then there's a higher potential on here than here. But I'm driving through the coil to ground. Like this will still have access to ground. It's got to go through the coil. And then this'll get the big discharge through the coil ground. That's not connected. Shit. Okay, that still doesn't work. I'm still okay. I'm looking at the loops. I'm looking at the loops. It's like we're gonna blow up our voltage regulator if I do this. Damn it. That means that my scheme of attaching this and cutting it off using the NPN isn't really going to be working out all that well. Only control, not see it in the circuit. I don't get that. Okay, so the thing is, I don't have PNP Darlington, so I can't do the low side and the high side. That's sort of what I was hoping to do, but I don't have the PNPs. I just have the TIP 122s, which were ordered a million years ago. I don't know why I ordered them. Probably to switch the ABS motor in my car. Here, let's get this out of here, just so I'm not super confused. So what I really want out of the circuit is I want the ability to cut off the input power collector and emitter in the circuit B to steer with voltage. Collector and emitter. Well, that, I mean, putting it on the high side, that's not really how that works. So NPN charging circuit or something. Let's just look that up. Yeah, these are a bit more catered towards high voltage. Using relays could also do it too, but I don't want to spark out my relays. No, no, not quite. Not my tempo. That's a weird one. Yeah, see, this is how you do the tip 122 circuit. 100 ohms, you get 42 milliamps, and then it would switch your big load. Relay with one side to charge, the other side to discharge. That's going to make big sparks, and that'll ruin the relay. So I don't want to make big sparks and blow up all my relays. I just want to charge some capacitors and disconnect them from the charging circuit and then blast them off onto a big coil. Oh, this would be a slightly different schema here. They're trying to teach you other stuff. Here's how you use one with a relay. And then, so I'm not sure. I'm not seeing the loops is what my problem is and why these things aren't going to pop off. I need to come up with a circuit topology that's going to do this for me. It's going to meet my requirements with only one type of transistor. Typically what you would be doing is flipping grounds to stuff. So I mean, technically, if I flip ground to these two and then flip ground to the capacitor bank, I guess that could be isolating in and of itself. So that would look like something like this, where you would have another transistor coming off of the bottom of this thing, just like before. And this one goes to ground. So that's sort of probably what Ben Gizmo was getting at. Goes to ground. And so all your stuff over here, let's move that meter back in. That's just the voltage meter. So then my circuit loop, I think, makes a lot more sense, in which case we have, no, but it doesn't, because when I connect that to ground, these caps would discharge to ground, and I guess, but they're cut off from ground. They don't have a loop. So I guess I can't do that. All I can do is keep those connected to ground all the time and trickle in 100 volts, and I can disable the power supply, but then I don't get my isolation through the transistor. Because I can't cut this off because this is an important part of the loop. My tiny little, this is the worst transistor I think that I've ever drawn. Hold on a second, I gotta redraw that. That looks like crap. Utter crap. Use an optocoupler, probably not a transistor. This is a tip 122. This is a Darlington array. An opto isolator. I don't think I have opto isolators that go up to 100 volts. So the PSU has an enable pin. I'd put that behind a 1K resistor just to keep it civil between these two. The circuit loop then, in that case, is a very tiny little voltage comes over here to the Darlington. A huge discharge goes down here, but that tiny little current can then loop back to ground, I guess, this way. Oh no, it doesn't do it that way. It trickles down through here, through activation, which is nice and direct. So tiny little voltage comes in, or current comes in here. That current goes down to ground there, triggering a cascade of a huge amount of current down there through the coil, which pops off our emote, potentially smacking me in the face. Yeah, we're thinking about the Darlington. I'm drawing the Darlington as a singular transistor. If this were a CAD program, I'd draw it as two different things. But in this case, we get away with this. And I guess through the enable pin, I can turn off the enable pin. I don't know if that means that anything's going to trickle back through the power supply. Let's see what that cutoff is like if they specify that in the power supply. But it means that we're just going to use one Darlington, and that means that my capacitors are going to be a little less safe. than I would like them to be. Although if we cut off the power supply, set off the big caps, everybody's inert. So that's probably the way that we're going to do that. If at first we fail, at least fail spectacularly. What Ben Gizmo saved me from doing, and the reason that I didn't like yell at Ben Gizmo just now, is that he saved me from having this thing stall. It's not that it would have failed in a spectacular fashion. It's that I would have put all the effort into building everything, and then when I flip the switch, nothing happens. And that's the worst thing you could possibly do with high voltage. Yell at me, it's fine. No. I'm saying there's a very specific reason why I didn't yell at you, because we're dealing with high potentials. We're dealing with a lot of energy here. We're dealing with a lot of energy. Unfortunately, the circuit ended up being a lot more simplistic than I thought it would be, but because this is like circuits 101, right? This is just how you set stuff off. This is the special sauce up here, our ability to disable the 100 volt supply. Yeah, and having a dead ESP, well, it might have been more than just a dead ESP. It might have like popped, which would have been exciting, but whatever. If I don't get a haircut by the end of the weekend, chat, you guys are allowed to not subscribe to me anymore. I've gotten past the part, the stage of growing out hair where it hurts, but I'm like, this is too much. Well, we're looking at one of the issues now. When we have 100 volts sitting pretty on top of these caps, is that going to feed back through our power supply in any way? How isolating is it? If your hair hurts, we have to have another conversation. It's because it's like super heavy. I don't have thin hair. Like I have amazingly thick, you know, I have a bushel of Hollywood shampoo commercial hair, right? Look at it. It's iridescent. It changes color depending on, well, how the light hits it. I guess it's normal hair, but if your hair raises up, you might have a high power issue somewhere. It would at least be lighter on my scalp. The other issue that I have with my hair is I'm looking for a good angle of this guy. This is the other issue that I have with my hair, is that I look too much like this fucking guy. It's stupid. Nope. No, I don't like it. I'm gonna get a haircut. I'm gonna get a haircut. I'm watching this show, like pointing at the screen, like, hey. Got a full fro going on over here. I can only tell if I can only tell it's there in a full downpour. Oh my god, I can't imagine that. No, I mean I could probably do like the hipster thing and like put it in something, but I can't imagine having an afro, like waking up and having a flat side on it. And then you got to pick it for like 3 hours to get it to be like afro-y again. It would be kind of awesome to have my hair go up though, because with it going down, it just like pulls me on it's bad. It hurts. All right, so do we have, it says there's shutdown current. I off is 15 milliamps. No, that's the current to get it to shut down. Shutdown input voltage, 1.2 volts. It's going to take 15 milliamps to make that happen. The efficiency, I don't really care about. I'm looking at to see if we have like a leakage when it's off. And they don't mention that anywhere. Barring like actually reverse engineering this thing, I am not sure. I guess we'll just build it. I guess we'll just build it. We'll just build it. All right. Ugh. I haven't done high voltage in a while. This might actually become a two-stream thing, is the high voltage thing. We got a little bit of time. at 0 volt when charging, no backfeed risk. Interesting to hear about hair problems. I have to take care of whatever is left up there. I have a neighbor who's bald, and I think not getting a haircut is flying up in his face about it. Because I'm like, man, my hair hurts. And he's like, yeah, okay. Must be nice. I'm like, sorry. All right, so we've got our voltage meter, which is like $12 on Amazon. How much can you trust this? I don't know. How much current does the solenoid take at 12 volts? 2 amps, so about 100 volts will be. Yeah, it's going to be quite a bit, but it's going to be a very short amount of time that it has to do that for. With any luck, it'll be okay. If not, it'll be funny. Those are our criteria. So, I want to test what the voltage of this power supply is. We can set it to something like 60 to 80 volts initially. Which one? High voltage is on the yellow wire. Usually do darker color wire for ground, lighter color wire for power. So it ends up being like yellow, and then the purple one is ground. So we'll do that. Bring that over to here. This one is going to be where 12 volts comes in, and that's coming in directly from the PSU on these. We'll do it at 12 volts. So I'm not going to try to put 24 volts to this thing. With any luck, I'll be able to find like a wall wart that's 12 volts, and we can run it off of that. That's really loose. Why is that so loose? My banana plug is loose. So that means I just need to kind of bend it out a little bit. These nano plugs, they go bad after a little bit, but what I can do is just stick a screwdriver in here and just kind of bend it. And that'll puff it out and make better contact. So just kind of twist a little bit. Work it in, twist a little bit. Easy peasy lemon squeezy. You breathe new life into your old contacts by just bending them a little bit. Last one there. There we go. Super tight. I got to do it with both of them. These are old. I've had these for eons, so they tend to wear out. While we're here, I might as well just do this, and then they'll work for another couple of years until the metal breaks. Okay, there we go. All good. Turn that on. Turn it to 12 volts. We can at least test this thing for 12 volts. Where's that? 10, and then probably the tick above that. Well, this is at 20 volts. So if I turn that on, this is showing, 28. Oh, that's pretty accurate, actually. One, 2, 3, 4, 5, 6, 7. 27.99. That doesn't look like 0.99 to me. This is going to be off by a little bit, but it should be decently accurate. Probably not as accurate as we desire, but still. Oh, and I guess, can I adjust it with this? I think so. Yeah, this will. It's got a little calibrator on the front. That's actually kind of nice for the money. Didn't spend a lot on this, but presumably it's pretty accurate. I guess I could use the big voltmeter and the big test meter thing that I have and calibrate it. All right, so 12 volts in. I'm going to need a pair of leads for that. pair of little shorties here. There's blue. 1, 2. Okay, and then I don't even need to unhook these. I can just hook through these leads. That's high voltage. Wait a minute. Over here. We're over here with low voltage. Oh, these will go directly into the board. Okay, cool. So we can do, well, that's 12 volt. We're going to want to measure high volt. So we'll just pull 12 volts in over here, because that's only going to go to this supply. And then ground, of course, is going to have to connect to all the other grounds. So we'll actually bust the grounds on the ground pin out here. So there's ground, and then this one is shut down. And then this one is input. Why is the blue wire input? Ugh. I'm not following my own conventions. It's going to lead to injury. Spark. Oh, whoops. Oh. Uh-oh. That was 30 volts into this thing. 19, 18, 17, 16, 12. All right, well, let's see if I blew up my power supply. I also need this to be measuring. We could have tanked I might have just tanked this entire project in that one little act that I just did. That sucked. I might have just killed it. I just gave it 30 volts on its input. This thing takes up to, scroll up on this, 24. So I might have overvolted this thing if there are no protections on the input. If there are, we're extremely lucky. If there aren't, I only connected it for a split second. This is what I hate about these terminals. I'm gonna put new. Yeah, we're just gonna go direct into it. God, it's so annoying. These DuPont connectors, what happens is I'll connect something like a multimeter into it, and the multimeter is a much larger pin. It's a much larger gauge. And so when I press that pin in there, it'll bend back the little springy stuff that's folded into the metal. So what you need to do is take the cover off of it and then bend it back so it has the springiness again. But if I don't do that, and if I get to a project that I'm trying to do quickly, like with you guys, I will plug something in like this that's totally reasonable and should completely hold on with all of its power, and it just just for a second to see how it sparks. Just see what it's like. See if there's any magic there. If there's any electricity. You know, that spark, that magic spark between us. High voltage is this one. Ground is this one. That's in there pretty well. These terminals aren't bad. These are good for like rapid prototyping. They're these like press down terminals. It's the 5-second rule. The 5-second electronics rule. So these, you need to like press them down. You can do it with a screwdriver. You can get away with doing it with your finger though. And it'll just give you, actually, wait, is that, oh, it's like designed for these types of terminals. That's cool. That's very cool. I like that. Yeah, I guess if I do them deep enough, that's cool. Hey, I did not know that. Yeah, everybody has like a billion farts to use. Okay, so what do they suggest over here for just having it power on? Float shutdown. Okay, cool. You got it, boss. I'll float shutdown all day. Is it not? Using these wire terminals with this breadboard, you can miss the little clip in there. You can miss it and like go to the side of the clip, and then things are all whack, and you don't get the right kind of power connection. So when I connect this, we're going to get high voltage out of this, or something spectacular. We're going to see a lot of heat somewhere. I don't know which one we're going to actually get. So I'll give you guys front row seat to the whole thing. You guys got to be my eyes and ears. Well over 100 volts. I am glad we did not connect that to anything. Now the thing is, I'm concerned about the calibration of this thing, of this meter. So I might bring the multimeter in, but let's turn the voltage way down. So here we should be at about 80 volts. And let me bring the multimeter into the fray. This thing is also not very well calibrated. If I wanted to be a stickler for this, I really could bring out the multimeter that Wexo sent in. That's is it B&O Precision or is it Westinghouse? I forget who. It's like a known name in multimeters, and it's a decently cheap one, but it's one that really does its job well. That's what I could use to like really tune this to the right specifications. But I guess we'll just try this with the thing all the way down. Oh, I need to hook this up to something. Well, I guess I can tap connect. I've got my high voltage probes and everything, so we can go like this. I can hold these at the very end because I don't want to get anywhere near the high voltage. Oh, that's on ohms. Volts. $89. So we really need to adjust this. Actually, that was at, oh, that was almost at 89. Hold on. Double check. So 89.3. So I take this to 89. That's this way. 89. Do I expose myself to high voltage by doing this? How insulated are the Wera screwdrivers? I see a lot of plastic here, but I don't know if these are static rated, which means that they would conduct, or if they are insulated. It's a very big plastic handle. I guess I'll be okay. Do we really take it all the way up to 100? Let's take it up to 100. There were no words for like working with high voltage in the data sheet. So, all right, we're taking it all the way up to 100 volts. I really would like that to go above 100, but you can test the handle to tip resistance with your meter. Well, it's too late. I'm still alive, so I don't think that's the worry. I think we're okay. Let's just fine tune to 100. We do 99. Whoa. $100.1. That's pretty good. I think we should stick there, I guess. It's not the voltage that kills you, it's the chat. I'm surprised nobody's tried to give me a heart attack yet. All right, power down. With that discharge. This is when we start to do really unsafe stuff with high voltage. I may stream tomorrow. I'm not sure. Oh no, I already said I wasn't. No, I gotta do chores tomorrow. That's right. It's getting to be planting season soon, so. I'm gonna have to do planting stuff. Okay, so so far so good. We're basically just gonna build the circuit, and the circuit has one tip 122 in it, and that's flipping the negative of everything. Well, it's flipping the negative to everything. Well, to coil and yeah, so this is one part of the circuit, and then this is the other, and then the third part is just connecting everything to the ESP to get it to work. Now we can initially just connect this, and then we can maybe set this off with a 12 volt circuit, maybe. If I do like a 10 kilo ohm resistor. Hold on, let's look up 12 volt tip 122. Not shopping, images. Hate it how shopping moves around. 12 volt tip 122. What resistor are we using here? That's a tip 120. Output from microcontroller. It's always microcontroller this, microcontroller that. That's just regulating. I want a switch. That's 100 ohms. There's no way that's coming off of 5 volts. I don't know. If I put like a 10K on there, is that going to be enough? I don't want to do math, so I'm just kind of eyeballing all this stuff. That's 1K on like a 5 volt output. Actually, that thing's connected to 12, but I don't know what its GPIO is outputting. I can't find a good example. Put through a potentiometer and wipe it up and down and see which one sets it off. Yeah, I'm gonna go with 10K through 12 volts temporarily, and hopefully we don't blow the damn thing up. So I need a 10 kilo ohm resistor. Got through holes sitting over here. What are these? $100K. I guess we could try a hundo. We're all about those hundreds today. So the tip 122, base collector and emitter. 1, 2, 3. 1, 2, 3. Okay. BCE. And we are NPN, so we are positively activated. So our base is the pin 1. So that's this one all the way over here. And our collector, which will go, oh, what direction does this diode go in? I need to know. What's that part number? Need all my part numbers up all at once, all at the same time. Need to be able to see everything. $1N05AA. Nope. N channel 60 volt, 60 amp, 60 volt. No, power MOSFET. That's the wrong one. Put the AA back. We had trouble finding this before. I forget what the, was it singular A, 1N05A? That's all datasheet keeps fooling me. Stop fooling me, all datasheet. All datasheet used to be nice. That's a MOSFET. That's not even right. I think we have the wrong part number. So back over to here. I don't think F30 up, but let's check. F30 up 20S. F30 UP 20S. Get P2 220 out of there. Look up data sheet. 30 amp 200 volt. There we go. So we want the number 1 larch. So we want the cathode to be on the positive end of the coil, which is what connects to the power supply, and then the collector of the Darlington is connected to the anode. So the anode is, oh my God, anode is there. That's pin number 2. So that's going to be this one. Goes to the collector, which hopefully is this 3rd pin here, and it doesn't have the base offset by 1. Let's double check that in just a second. Let me just get it in here. Get in your breadboard. The leads are bent all over the place. All right, so like that. And then the tip 120 has the collector on the it's in the middle. Well, luckily for us, the collector or the diode skips a pin. So we can put that right up against this other piece. There's just hair all over the place. Like this. then our collector goes to the high voltage power supply and all the capacitors and stuff. Would you just... That's a... I think I'll put this on the end. So that's on the end where it can explode. And then this will go right here. Where it can also explode. And then we have our cap bank and our power HV input goes in there. So HV input, we'll get 2 jumpers for it. 2 more jumpers, please. Jumper. Slightly longer ones would be nice. So we can jump this whole way. That's much longer. Damn it. I always feel like Professor Farnsworth when I bring out the little jumper wires. This one's way too long. What the heck? Whatever. Use funky colors. This one and this one are our high voltage. So ground is unfortunately shared on the high voltage. Probably not the best practice. But it is that's what I'm faced with. That's what I can do here. And then the large amount of current that'll be heading through. I guess I'm not going to have a bleed off resistor because this thing is only a couple milliamps. Although it would probably be good practice to put something like the 100K in there. So you know what? I'm going to put a 100 kilo ohm resistor on it. Yeah, to smithereens, you say. Was this apartment rent control? So to jump this gap, it is pretty much the width of the resistor. Well, and then a little bit. So I'll use the fancy tool. I can't stop using this thing. I can't stop using this thing. This is a bespoke through-hole prototyping tool. Pace makes it way too expensive. It's like super expensive, but for some reason, I can't stop using it. It has all of the exact right like bends and distances on it for working with the solderless breadboard. Heading out for alcohol consumption. Chat, can you please clip any incidents, please? I don't think we're going to get to powering this up today. I don't know. We'll see. We'll see how far we get. We might have to wait. So 100 kilo ohms on the high voltage output. Let's just organize that a little bit. This is like all over the place. Well, I guess I can't. It's gotta jump over like this. So high voltage output right here. V out here. That's 100 volts, which is ridiculous. And then ground to ground over here. So like that. There is that hooked up. And then we have our meter's going to be on the other side of the feds. No, it's still on this side because everything connects to the same thing. So this is going to go from ground over here to the other side of the 100K so that we can measure what that capacitor bank's voltage is. Actually, it should go to... Wait just a minute. Oh, this goes to the collector. So this actually goes over here. And that base goes to ground. I'm going to give these a little bit of room to breathe. Actually, they don't have that much room to breathe. I need to connect the bank somewhere, so I'm running out of pins. Tweezers here. Move the resistor back one so I've got space. Because yeah, the pin number 2 is the collector, the middle pin of this thing, and that's where I want all of my power stuff to go. And then the base is the base over here. where does the base of, hold on a sec. The collector I want to be permanently connected. The emitter for the diode is connected. Okay. Power on both of those. So, well, that's already connected. It's this power. This is on the other side of the 100 ohm, and then we connect our big bank to the whole thing. Now, the breadboard is not going to like this at all. It's probably not going to like the amount of current that we're putting through it. Although it is very quick current. I don't know. There's potential for things to go kind of wrong here. What are these resistors? 470 ohms is probably pretty good to connect to 12 volts. I really don't want to be fiddling around on this board, to be honest. I think we'll connect the ESP to the tip 122. That way I don't have to be standing on it when we charge this up. This is a shitload of capacitor that we're charging up, so I'm a little nervous about this, if you guys haven't been able to tell. I'm just prepping a 470 ohm resistor. We saw from 5 volts, these things had 100 ohm resistors on it for the tip 122. So I'm putting a 470 ohm on 3 volts. So it's going to be all right. It's going to be enough resistance on there. It should trigger still. Now, this computer restarted, so I don't know what pin we put everything on. So let's open up Arduino. ARD, there we go. Arduino. I'm going to let that boot up while we hook up everything else. We're almost there. We pretty much just have to connect the grounds and then the whatever's. What do you call it? The grounds and the two 1Ks. Ooh, Arduino's available. Nope. And open recent. This one wasn't the channel point fart. It was, I guess I got to go to open because I moved everything on this computer. It's going to be on the desktop, but it's going to be on the stream project. Fart node, ESP node, skeleton, solenoid skeleton, 314, 38. So this one's the better code. Open that up. Oh, hold on, I'm prepping a resistor. Instead of 1K, which I would have liked to use, these are just going to be 470 ohms. So these are the two outputs from the ESP. Although we can just keep the 100 volts on for the duration for the initial test. So I'll only need the one output, but eventually it'll become 2 outputs. Okay, why isn't that cooperating? Here we go. Just for the ease of setup, we're just going to stick with one for right now. So what pins are we using? Guess we can keep debug on. Punch box. Solenoid pin is D0. So on to 0 pin. Go from D0 to by all means, it should probably be through an opto-isolator, but here we are. So from the D0 pin, we have our solenoid output. Our shutdown we haven't figured out yet, so I'm just going to float the shutdown pin right here. And then I need a jumper to go from this pin right here. Actually, we can go horizontal with this. Might as well reach out. All the way over to the base. So that's a long jump. I need a long jumper. One of these guys. shorter than that. Well, that's that mid-length that I don't have. That's so annoying. Green might be the right length. So my other big concern here is that this thing, plug it into USB, that means that it's plugged into my computer. So any big surges or weirdness that I experience might feed back all the way to the computer. I don't know if this is the best idea, but we're going to do it anyway. So I've got base connected. Now we just need to connect everybody to ground. Ground, ground, ground. Everybody needs ground. Ground is the close pin, and it also goes here. So ground to there. I need a slightly... These jumpers are the ones that are hard to find because you use them in every project. Every project needs these little jumpers to ground, and so it uses up all of your appropriately sized jumps. But the kits are cheap, so you just buy another kit. Just buy another kit. Get all new leads. Okay, microcontroller's hooked up. Tip 122 is all the way over here. I need the ground pin here to go to there. So we will get... This is going to be a high current kind of thing, though. But the minus pin over here is what... Okay, hold on. Do you have a throwaway computer? No. No, it might blow up my hub. All these are connected to ground. The transistor is as well, because that's going to be a big current flow through there. Yeah, because it's going to be like through there. That's weird, though. Is that weird? That is weird. Got all this potential sitting up here, and then it goes thunk through the coil because it finds that path. Leakage will go down through there, but it's going to be supplying up and around. Yeah. So this needs to be a big ground. And it's not. It's not a big ground. Oh, boy. Something is going to get hot. But wait, those are connected ground too. So maybe if I put like a big terminal on the ground pin for this. So I need to go get wire. I need to get wire because we need to hook up our big capacitors. This is where the rubber meets the road here. Things are going to get crazy. We need to make a big high current connection. But we're not going to be able to do that. It's going to be... This is... Oh, boy. What gauge wire do we have here? I think 18 gauge wire is probably going to be the best for this. Silicon jacket will give me a little bit of leeway. So I need to actually find where the wire is. It's all the way over here. All the way over here, up on the shelf. The wire shelf. The shelf of wires. Yeah, this stuff will do. This stuff will do, and hopefully it won't get hot. We're dealing with higher currents than what anything is rated for over here. So we've got to be kind of careful. I have the ability to work with much higher currents. It's just that this is an initial test. We use the classics. Black and red. We'll take a bunch and then we'll cut it up as needed. Reach out and touch faith. You're wrong. That's enough. Jesus. That's not going to do. That'll also not do. Well, we can use both. Originally, these are used for my big computer power supply because I use Vicor modules, and they use these solid-state switching things, but they also require... These don't work together. Damn it! They also require the huge capacitor bank in order to stabilize all the voltage, depending on what your setup is. So I have only a few of these. That's not really gonna... I won't hold them in line, which makes soldering them kind of annoying, but I guess I could just do it this way. You just do it this way. Okay, get this out of the way. Wire strippers, and the wire is over here. These are very thin for what we're asking. Really, maybe I should hunt out my 18 gauge. Oh well, let's just go. Doing things is greater than not doing things in this case. Oh, you know what I can do? I could use, I got my big solid core wire up here. Where's that stuff? It's way back here. Yeah. This will be good. This will be good because it'll structurally it'll hold it together too. You're free. You're free to go. Get out of here. Big capacitors are scary, and it's a healthy fear. Very, very healthy. These will fuck up your Wednesday. Not even Wednesday. That'll do. Soldering iron. Didn't know we'd need you today. Good to see you. Good to see you. The wire's going to heat up before I'm able to solder this, isn't it? How these always go. This thing isn't tinned. This wire is very oxidized. I'm really asking a lot from the solder. Ouch. It's starting to get too hot. What? Not going to make a ton of contact over there. Let's do the ends first. Do the ends and then I'll bow it in the middle so that I can make slightly better contact. This is not tinning at all. Okay, hold on. There we go. Nicely tinned. What's going on in chat? Nothing. Whole lot of nothing. Bow it down in the middle a little bit so we get a mid pin contact like that, and then I can solder that in. This is a lot of capacitance. I hope it goes to good use. Come on, buddy. Is it actually connected? No. No, it is not. These are better if I put them through like breadboard. Which is probably the better option too. That's not really soldered all that well, but I want to make the second bar, the second bus bar. I guess copper tube I could also use. I've got all that brass tube sitting right over there. Just put a big section of tube from spot to spot. could have soldered pretty good. Oh, this will do fine. In the ends. That took tin pretty well. I want to cool off so I can grab the other end. It's not cold. Working with these with an actual circuit board is always fun, but I had, actually, no, I don't think I had an actual circuit board for any of the circuits for these. Did I get one printed? No. I think I remained with the, I did do a better job of housing them on the computer project, but we never, I haven't used the new Vicor stuff. I've got enough of the modules to make a 1,000-watt power supply, which is something that I wanted to get to. But I haven't done it. I haven't had time. A lot of CAD design for that computer, and now that I have that little handheld to go to LAN parties with, I sort of want to relegate the computer project to its own stuff. Like, I don't really need it. The computer can stay here, so I need to redesign the layout of the cooling system so that bubbles find their way out, because that silicon tube leaches. I don't know what it is about that stuff. Like, after like a week or two, I will have like a significant amount of air inside of the system. Very annoying. So I don't really need to do the Vicor power supply thing, even though I want to. You guys need to connect so that I can solder you. Maybe we could get this on here. Yeah, the Vicor power supplies are really cool. You can put them together, and they communicate with each other in order to supply equal amounts of current, so that they can do just the right amount of current into your system. They're used a lot in like laser systems and like research stuff, where you need like a really clean, nice power supply. They're super efficient. I like them a lot. I should be sponsored by that company, but I'm sure they get all their money probably through defense contracts. Because that's where I originally found out about them. We got some equipment in during the IED job, and I studied it, and it turned out to be one of their power supplies. And I was like, man, this circuit design is really good. Look at, it's just like not attaching properly. I think that's okay. It's not quite what I'd like. That's more like it. I think I just have to apply quite a bit of heat and just leave it there for a while. Let the flux do its work. It's not good to apply heat to a capacitor for so long. It's not great, but it is connected. All right. Now for the very, very high current wires. These are not that high current. Good Lord. Good Lord, what am I building? Building an accident is what I'm doing. Wrong. That's enough. Jesus. I want to be your friend. Oh, no, it's your own personal Jesus, right? I have the wrong lyrics in my head because I learned these songs were new when I was a kid. I just whatever sounded right. No electro boom. Yeah. Now we're gonna keep this. If you put flux on them, are they flux capacitors? No, and you should leave. If there are any big booms today, they are not going to be intentional. Owie, 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 owie. These are hot as hell, so having all that solder there helped the wire to attach really nicely. Now, what I'd like to do is put some leads on these. Not connected. They're going to be completely separate, but just because these will interface with the prototyping board a lot more cleanly. Now, in order to solder a big wire to a lead like this, you can't just solder it straight away. I mean, you can if you're psychotic, but soldering it straight away would melt the pin header. So what I do is I plug it in to the breadboard, and I use that as a heat sink for soldering. That'll hopefully preserve everything. So we'll make it nice and short. I don't want too much resistance on this. Ah, perfect cut. My perfectly sharp cutters. Yeah, there goes the ideal light. Good idea. Yeah. I know it's a good idea because I had it. It's my idea, so it's good. All right, excess stuff needs to get out of the way. We're working on top of several hours worth of doing project stuff, so I need to be cautious about what's where. I need to keep my head on a swivel and not make a tired mistake while rushing to be done for the day. We got to keep an eye on the capacitor heat. I don't want to see any heat coming out of these caps. We're not a channel that does drama explosions. While it is fairly popular to have stuff pop off on stream, I just don't want to do that to myself today. Scare the people upstairs. If I was home alone, maybe we would want to blow one up, but I don't know. I just don't think it's very responsible to show people that. You can work with high voltage if you really absolutely want to do it, but you need to have an abundance of caution. And the caution needs to come from a place of slight experience with higher voltages. You can use the hand behind the back rule if you're dealing with high current, high voltage, but generally just checking over your work, being safe, following instructions, stuff like that. All right, so we've got our tip 122. We have 12 volts ready to go over here. Our Arduino is not plugged in. We have a 100 volt supply that is going to go through a 100 kilo ohm resistor. So it's going to drip feed milliamps into this thing. Now 100 volts through a 100 kilo ohm into a bank of capacitors, it's a little scary. All right, let's see. Hold on, what am I hooking up? So the negative of the tip 122. So the negative here, which is going to be that center pin. No, it's going to be the pin all the way on the right. BCE, right? So the emitter there is hooked up to pin 3. So this pin on the end and the coil is going to go to high voltage caps over here. And that's also going to get a trickle feed. So I need this here. Okay, hold on. Not yet. We've got like a couple minutes of me hooking up grounds and stuff. So this one's the kind of weird one. So that one, oh, okay, I see. This is where the bank goes. Cap bank goes there. And then, well, let's hook it up on this side. Or maybe I don't have room. There's a lot of big things. Tweezers, tweezers. Where are my tweezers? We're going to open up a wormhole. Light's going to flash. Blinding light. Kind of need to hook this up differently. I don't like the way that this is everything's crammed in here. So, let's see. There's our diode with our coil. And that's hooked up across the main coil. These things are all messed up. That's there. Why do you not? God, this thing is just aggravating. I guess it's because I didn't spin the pins, but I don't want to spin those because they're going to be used elsewhere. Hair. Just hair everywhere. God. Release me from this torture. All right, so there's our positive from the capacitors. Here's the meter. Getting a little cramped. I think maybe I want to relegate this to two tracks instead of one. Well, that's all I need to hook up there, right? So we've got the coil, we've got the anode, we have the collector, because it's BCE, collector, we have the capacitor bank, and then we have our 100 volts trickle charge coming in. Our 100 volt trickle charge coming in. Then over here we have ground and ground. So both of these need to connect to ground, and they need pretty big connections. This one is unfortunately going to have to slink around. This wire is going to not be very happy with us. Tweezers, there. I don't know if we're going to melt this wire or not. We might get away with it without it. Need a very tight bend to the end of this thing. Ah! It just jumped out of the tweezers. Where did it go? I really want to test this before we're done today. Okay, so that one has ground. Now this one needs ground too. So I'm just going to get an equally large. I mean, these are decently large. I just think they're a little undersized for the amount of current that we're going to be putting through this thing. But for testing, I think they'll be okay. Famous last words. These really should get like a bypass. Like a big wire. It's going to be shite. Okay. That I missed. Wait a minute. Shit. Rubber one. Okay, so there's that direct ground. So the anode is connected to positive 100. Cathode goes to, that's wrong, goes to the other side of the coil. Oh no, okay, yeah, I messed it up. So that one does still go to ground. It's just this one goes to positive 100. Wait a minute. Fucking goddamn it. The emitter goes to ground. So that's the pin on the end. The collector goes to the coil. And then the other one goes to positive power. Positive power does not run to the MOSFET. You do not go to the MOSFET. You do not go to the MOSFET. The coil sits on positive 100, which is this. This is positive 100. on this side of the thing. So that was the mistake. This is positive 100. And then this is positive 100 over here. Let's see if we can do, kind of sneak these in. This and this. This goes to ground. That's our cap bank there. So positive, positive. And then we're switching it to ground like right there. It is where ground is, I believe. Oh, you know what? No, this one skips. So ground is actually out here. So I need to redo this too. Jesus. Come on, man. I can do better than this. All right. I'm ripping this up. Let's start over. Let's start over. Move this ahead one. Get this out of here. I've got both sides wired up. It's positive to positive, ground to ground. The ground is up here. Yeah, okay, that's how that works. Okay. All right, so let's rethink this. I got it. I got it this time. So anode and cathode, and then our positive 100 volts here is going to this lead. This lead here. This is 100 volts in. These two are the diode and the coil. The positive 100 volts also goes to the power supply on the other side of the resistor, to the meter on the other side of the resistor. Any one of these, I guess. Positive 100 does not hit the tip 122, but it also goes to the power bank. Power bank is here. That connects here. And then the negative here, it goes to the negative on the outside of the board. That's correct. Okay. Okay, we're getting there. We're getting there. We got this. That is a little bit far away for the capacitor bank, but I guess it's okay. Base collector emitter. The collector connects to the coil and the diode at the cathode. No, at the anode, because the diode's upside down. So the diode, the cathode goes to positive 100, which would be the pin on the right, and the pin on the left is the anode, and that goes to the tip 122 on the collector. Base collector emitter, boop, boop, boop. Base is the control pin, collector goes to there, and then the emitter goes to ground. So we need a big ground wire here. Love it if it was a larger wire than what we have, but we've got what we've got. Okay, pretty sure that's connected. It didn't feel good going in. And then we go doot, doot, doot. I've got a 400 and something ohm, 470 ohm resistor going back to our 3 volt system. Come on, bud. These things never get along. It should just slide in, but some of them are like hitting the edges of the clips. There we go. Okay. So my 1 amp max current breadboard is all set. Thread the needle with this, under it so that it's not in the way. So, which one's power and which one's ground again? Ian is blue. Okay, so 12 volts is hooked up here. Yeah, I think we're good to go. Somehow it feels like you're making a toaster. I feel like I'm about to die. This is very nerve-wracking. So our positive powers and everything are hooked up supposedly correctly. This is when I can give it a burst from the power supply to see whether or not we've done everything correctly, and we can very much pay attention to heat, because that's going to be a big deal. So I've got 12 volts on the power supply right now. If I hook this up, this should charge the capacitors. Double check my work. I think I'm good. I think we got everything correctly. The purpose of the hole, it's so that you can screw a heatsink to it. So that tab does a certain amount of heat sinking. Then when they did surface mount technology, they took the same form factor, but they got rid of the screw hole because they figured you're just going to solder it directly down. Now on this one, on the diode, I don't know why there would be one on the diode. I don't know why there would be one on the diode. I think it's just a matter of we put it into the machine that makes it look like this, right? Like the diode is 2 terminals. That's a piece of plastic. So you're not getting heat out through that, I don't think. Maybe it's just so that it can go into areas where you would have it screw mounted. This doesn't seem clear to me. Oh well. Okay, you guys ready? I'm not. Minus is definitely on minus, plus is on plus. I'm going to maybe take a step back from this thing. I really don't want to power this up. Is there heat anywhere? I don't see heat. We're not really charging up either. It's kind of stuck at 50 volts with this thing warm. Is that charging? I stood up from the desk and I took a step back. I'm like back here. Maybe it's charging way too slow. Thing is, I don't want to stress out this power supply. There's the caps are a little warm. Those are looking a little warm. Tip 122. Nothing. A little bit of heat in the caps. Don't you dare. Part 2 of the test involves plugging USB in without shocking myself on this and allowing for you guys to set this thing off and flip the transistor, and hopefully the whole circuit doesn't go dead. What is, oh, we're drawing very little current. I think that's what's going on, is that I'm not really, whoa, when did that do that? I think I was a little too chicken about this whole thing. But where did all that initial current come from? Trickle through our 100 kilo ohm resistor. All right, you guys ready? I'm going to do an awe emote. 3, 2, 1. Well, that was a discharge. That certainly did switch the tip 122, but we got absolutely nothing else going on here. You guys see that? We're only charging up a certain amount. I don't know where. They're not all charged up. No, they're charging to like half. You can see when I do the emote, there's a dip. When I dip, you dip, we dip. I can't touch any of this stuff because it's at 100 volts. Ground is hooked up, positive is hooked up. It could be that 100 kilo ohms is hitting us. It should be, it's like a trickle feed, but it seems to charge up pretty quickly. It's just not getting up to its full potential. It should be getting up a lot higher than that. Maybe it's the power supply doing that. If I crank up the power supply's voltage, that doesn't seem safe to me. Plus, nothing is happening with the coil when it activates. God, putting 100 volts through a coil is a little bit harrowing. Surprised everything stays cool. Yeah. Well, it's intermittent. It's so quick that it's not enough to really heat anybody up. Yeah, like everything is nice and cool because it's just intermittent. So, I mean, theoretically, everything worked just fine. I just don't know if we have enough capacitance to do something with that coil. That or there's some other fallacy in what I'm trying to do here. The ESP is alive. It did not die. That's always nice. Do I have, I think I got a button on Node Red for this. Don't I? Contains idea, fart. Point redeem, fart, message payload. Okay, I don't. I'm gonna add an inject on that. Payload. With that. Oh, that's fart. Wait a minute, that was the wrong flow. Excuse me. Wait, where's the Oh, it's up here. I'm getting that signature smell of hot electronics. Is that fed over here? Just short the GPIO for testing? No. So, doot, 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 doot. Where's the, I lost my mouse. It doesn't appear to be doing anything to the coil. Could it be that the diode's in backwards? Could I have gotten that wrong? That or the trickle feed is just not enough from the power supply to charge these huge caps. Because we put a 100 kilo ohm resistor in there, it's just not going to make it. We're at 50 volts. We're at half of our total voltage. And I think I got the circuit correct. I don't think there's anything wrong with the circuit. Dealing with 100 volts is rather harrowing. If I bypass the current limiting resistor, that's going to hit it with full power immediately. Is that a good idea? What is hot on the Arduino? That's just the radio stuff. It just gets warm. These ESPs are like that. Because then I could use the temporary pin, and if we just hit it with the full, is it going to think that it's shorted out? So if I cut power to the circuit, oh, that bleeds off on its own pretty good. Well, good, now we know. And then I can just set it off just for fun. That drops this a little bit, but it still comes back. It's got like a 1 volt latent current on it. So I can then safely work on this. I hope. Here, why don't we do this? Okay, safe to work on. Get this resistor out of there. And now we're going to hook it up directly. And hopefully it doesn't explode. I don't think it'll explode, but I am kind of nervous around it. Rightfully so. We're dealing with a lot of energy here. All right, I'm backing far away. Jesus Christ, that's scary. I don't like that. That went immediately to 100 volts. What do the caps look like? Do they look hot? They look okay. Oh, Jesus Christ. All right, ready? 3, 2, 1. Whoa! Yeah! 3, 2, 1. Oh! Anybody getting hot? Everybody looks okay. That's a pretty good smack. All right, power it down. We're engineering. We're doing it. We're doing it. We're engineering. I need like something that I can fly off of. Fat, do you know what I just built? Holy shit. This is a capacitor charge and discharge. This is going to be way too violent for that. That works at 100 volts. The power supply got warmer. It's not up to the ESP heat yet, so we got that going on. I can just do like that. Yeah, that's pretty good. All right, let's see what this thing can do. I don't like this one bit, but we do have the advantage of it discharging very quickly. Not quite. I mean, yeah, sort of. You'll notice 100. It charges up too quickly, to be honest. Ready? 100 volts. And then I set off my emote. That's pretty good. I can work with that. I can work with that. See, what I want it to do is present the emote. I want that to be visible. And then when somebody puts it on, chat, I think if I stabilize the base a little bit more, it'll be good. I think it'll be just enough energy to actually toss this stuff up in my face. But this is 100 volts. Kicking a emote at me. I could use a little bit more power on it. But I'm out of volts. I don't have any more volts. I can't go above, at least with the meter, I can't go above 100. It's a pretty good kick, though. I think if I stabilize everything, it'll be good. That's actually not that good. That's not that good. Yeah, that's not as good as the other kicks we were getting. And I guess I can get over that with more capacitors. How are we doing over here with heat? We're doing okay. With some slight configuration, I can defibrillate myself after having destroyed my heart by touching the 100 volt rails. We're building an interocitor. More caps. I don't want to put more. See, okay, so the trajectory of that one, it had it going like this and it almost hit the edge of the table and I was able to catch it on my leg right here. What we were doing yesterday, we had the emotes flicking up in the air, which is what I want. I want that more like the Tom Thinks, where it like flips around. So I can do that. I can make it do that mechanically. I could try the other solenoid maybe. This thing at 100 volts with less coils, I guess. I don't know. I could maybe put more caps on the bank so that it really has a bunch of punch. What I'll be able to do is, given the timing of how quickly the voltage is coming up, and maybe we'll try to boost the power. I don't have more of these caps, so I'd have to find more caps. But given like we can time that charge up, and so I can have the power supply enabled for that charge up, trigger, and then it can turn off, and the voltage will go back down. Yeah, mechanical advantage maybe. I don't know how much power is behind this. I'm going to guess there's a lot of power behind that stroke. I don't want to hold something that's 100. See, this thing is moving when it strokes, when it strokes out. It's so violent. It definitely makes a pretty big clicking noise, though. So I could put a Heim joint on the end of that, and then we could add some kind of a mechanical advantage to it. So it'll, I mean, if we want, we could do this thing. This thing linearizes the stroke. Might be a bit much though. Boom. Yeah, here's the circuit, by the way. So we talked about it for a while, and Ben Gizmo was needling me about it, but we eventually went with the most simplistic form of Darlington switching circuit. I happen to have a bin full of tip 122s, which are a really, really nice jelly bean part for this. So we've got a big cap bank here. We have a trickle feed, which is actually no resistor here. We have a feed in of 100 volts coming from a Nixie power supply. So that's like 94 milliamps or something like that. That charges these in something like less than a second. And we see it on the voltmeter. And then when the coil goes off, it's through the tip 122. Tip 122 turns off, and then our back EMF goes through a very large and bespoke motor flyback diode. So it's all very civilized, but we need to build a little bit of the mechanics around this, and I maybe need to build a perf board circuit for it. And then we can try to get this thing to actually have some kind of a mechanical advantage in kicking out the emote. This one was 12 volts, 3 amps. This one is significantly less amps at 12 volts. I wonder if that means it'll kick harder or not at 100 volts. I don't know, because it doesn't have a spring on it, so damn it. But all we want is that punch, and you can see that all of our caution around the voltage and the amount of current means nothing, because we're activating it for only a couple milliseconds. But yeah, if this has a lot of heft to it, then maybe we can multiply the force out. That was 100 volts right by my hand. Jeez. This is locked in better. Replace with mag rail. What is mag rail? Yeah, electrocute bother project. Chat is out for blood. That's like one of the fundamental. None of this is going to come up with the right stuff, huh? Oh, that's just basically unfolding a motor. Keep my hands out of the pinch points. Yeah, yeah. You know, you want to. Why didn't it catch that? Did I? No, everything's powered at 100 volts. What an absurd voltage. Yeah, it doesn't really kick it, does it? Whoa. It gets it to the floor, and that's it. Although kicking back like that is probably not good. So I'll just prop this up like that. Oh, it's loose in there. It needs to be solidly in the vise. No, that's not working. Too back heavy. That's not even propped up. I gotta watch it. There's 100 volts across those 2 screw terminals that are completely exposed. Maybe you need to disconnect to pause. Well, okay, so for right now, dramatically speaking, this is fun and funny. But in the future, of course, there's other stuff. Whoa. I mean, the Arduino is going to have access to the enable pin. So I can have it enable to charge, and then when it's disabled, it's safe. So for the most part, these caps will be safe. We're in a very unsafe mode where we've just got power permanently connected. But I mean, it's as easy as doing here. Let's do back into Arduino. Our punch box. So when we when we do the business of punching, oh yeah, we need to add the other pin. Actually, my arm needs to occupy the space where the camera is. But let's see. So we add a pin. So define end pin is D1. Yeah, we'll do that as D1. End pin is D1. And so we look at where we do sol pin. Sol pin. So we sol pin down here, pin mode, sol pin output, pin mode, end pin output, and then digital right, end pin low. So that turns on, actually, wait, that turns on the power supply. We don't want it on or high. So we want it, wait, which way? Hold on. This is the last little detail that we'll do, and I can show you guys this working. It'll be pretty cool. Where's my window? All my research for nothing. Nixie power, and then through MCU, high is equal to off. So we want it initially off, and then way down here, where we do the business of actually doing this, then we do digital right end pin low, delay. We'll give it dunno. We'll just give it the same variable. Actually, no, we'll do all the way up here. We're gonna have dunno is our timer. Oh, the timer is what's passed in from MQTT. So I'm just gonna make a define up here. Where's settings? Just regular settings. Define charge time. I could add it to the MQTT coming in, but I'm just going to do this manually. So charge time, I'm going to give it, hold on, let's take a look. Any reason for staying in Arduino 1.8? Simplicity. Originally it was so that, well, laziness. Originally the reason that I stayed in the older Arduino was so that people could see the same like thing that they would be introduced to Arduino with. If I'm programming something and I'm doing this big, super complicated project, like I'm trying to take over a wireless device and spoof it on a TX and RX, which we did all through that IDE. You can do amazing stuff with a regular old Arduino IDE. You don't need all the special funky fritzy tools, right? That's what I was trying to get across. And so people starting out would be able to kind of jump off and be like, okay, I just didn't bother to do this. Now it's because of laziness and I need to upgrade. The last time I tried to upgrade, Arduino didn't like start up. So hold on. That's pretty instant. I'm going to give that like a half a second. We'll give it 500 milliseconds. So charge time 500. And down here, we're going to go charge time. Charge time, up here it's charge time. Yeah, charge time, 500 milliseconds. I'm doing this with delays, which is kind of lazy, but oh well. I think it's less, I think it's 200. Let's give it 200 milliseconds. And then tools, port, COM7. We've got debug we can set to 0. And we're punch box, PCMR, dead beef, 220, punch box, 1883. All that stuff is set up, upload. Oh, I should have put that inside of the debug thing. Still trying to figure out Platformio for VS Code, but I always go back to Arduino or Atmel, Microchip Studio. Yeah, it's, you start thinking in the way that you program for these things, and it becomes sort of a go-to. And then we need to hook up D1 to this thing. So let's disable this for a minute. And then D1, oh, what happened? Okay, I'll fix that in just a sec. Let's put our hardware together. I'm very glad that this thing discharges immediately. That makes me feel a lot safer around these giant capacitors. So where's D1? D1 right here. D1, boss. That. We get our 500 ohm. That across here. Pow! And Bother's dead. They're just like a sack of potatoes. It wouldn't even be like a spark. It would just be like, but. I think my move is going to be to upgrade to the modern IDE for Arduino. Just use that. Because again, it's whatever people use right off the bat. This, I just bent the lead for the resistor, and now it's like just annoying enough. Really annoying. So more capacitors would mean that we would be able to discharge slightly longer and meet the timing that it got for us to really launch it out there. The 100 volts turns out to be just fine. Okay, now I'm going to reconnect it to 12 volts. That should not be enabled. Wait a minute. Restart this guy. Ah! Jesus Christmas. Jeez. Dying on stream is toss. Oh, man. Oh, that's right. We didn't upload the code yet. Okay, so I forgot to do this. And now I can upload it. It is against toss. Yeah, I would have my channel banned, which is very unfortunate. It'd be kind of disappointing. Get through the code. Do it. Oh, God, full compile. This computer restarted after last stream for some reason. What we should see is this voltage drop. And then when we go to fire, it'll go zoop and then pop. It's still compiling. It hasn't programmed yet. Give it a chance. Give it a chance. That was not giving it a chance. 21, 28, 35, 42, 57, 64, 71, 78, 85, 92, 100%. Maybe I get a reset over here. Ah! That's fucking scary as shit. So what happens if I go to shoot my shot? Oh, wait, what happened? Wait, huh? Oh, it doesn't reset. I didn't put the reset in there. Womp womp. Let's go back down, all the way down here. Lots of motion at the front door today. Upload. So that'll enable it, and then it'll disable. Oh, shit. I'm not going to get it in time. Ah. I wish I could stop this. I wonder if on the later IDE I can stop it. Jesus, that reset is harrowing. Wait, it didn't spring back. What the hell? Whoa, that just held it closed for a little while. Okay, so let's upload this again. Look at that, it doesn't go all the way back down. It stays at like 6 volts. I wonder why. I wonder what's bleeding through. This should be high. That's 3 volts. This is getting hot as hell. Why are you so hot? Why are you hot as hell? Probably because it held closed for... Oh! Yeah, like that during programming. That seems a little unsafe. My wires are warm. Jesus Christ. Everybody cool off for a minute here, okay? Just take it easy, all right? There's a little bit of airflow, but this is staying at 5 volts. It's very strange. I had to check them on 2, 3, 4 and compile as a cancel button. That would be nice. So now it's at 5 volts, so it's relatively safe, although that seems to be getting pretty hot, but I think that's because it was held down. And they say as long as you just have airflow around it, it should be pretty safe. But now, if I do one of these, I think that's kind of pathetic. I think it needs to be more than 500 milliseconds, it seems. Maybe it's just the new setup. Like over here. Somebody want to pop me off? I'm going to get 12 of them in chat if I'm not in control. I think that's a little bit more pathetic. I don't think we're charging up fully. That's 200 milliseconds. I didn't observe that time and see if we got all the way up. I'll do it with a button. You guys can't predict. It's better if I do it with a button because it's a little bit more readily predictable. Just need to find the window. There it is. Window on my computer. Oh yeah, that's firing mid charge. So we need like 400 to 500. Let's go to 500 milliseconds. That way it can do its full song and dance, and then pow. There's a lot of motion at the front door today. Charge time, bopping it up, 500 milliseconds. Well, this is why I had that command in MQTT. And I could add a field in the MQTT that would give it a charge time, but we'd have to parse through the string in order to do that. It was going to 0 volts when I disconnect 12. I don't know why it's going to 5 volts when I have the 3.3 volt thing doing its thing. Oh boy, it's gonna, please turn off those pins, ESP. Please, you're burning my whole circuit up. Jeez, cool off, man, it's okay. Having that charging noise that little camcorders would make would be neat and all, but I don't think I'd want that. It's kind of an annoying noise. Yeah, the bwee, the what is it? The game, not Snake, the Sam Fisher game. That was I was watching an old man lose all his memory. Is the worst set of night vision goggles that I've ever heard of in my entire life because it has 3 green lights on the front of them. Splinter Cell, there it is. Yeah, Splinter Cell. We played all the way up until that dual Splinter Cell game, and then I haven't played any newer ones. The one where it was like you and a buddy infiltrating, that was a fun game. But having a night vision goggle that has 3 green LEDs on the front of it is like the worst design that you could possibly have for a night vision goggle. That is the worst design that you could have for a night vision goggle, because expressly you are using night vision to not be seen. And so it's the same thing with like future guns having lights on them. Having an LED display on your future gun is really, really bad. The last thing you want to be doing is announcing yourself with a light. Here I am, look, hey, here's my light. That's so much cooler. That is so good. There's just like a little bit of a dwell. It's like 100 millisecond dwell where it just sits at full power. But it looks so much cooler. It's so much more theatrical. What's up, Disco House Days? What we did is we hooked 3 giant capacitors, the only 3 giant capacitors that I have, to the thing that kicks emotes whenever somebody puts an awe emote in chat. If you'll notice, our voltmeter goes up to 100. It goes all the way up to 100. And I have a Nixie power supply right here. So the Nixie power supply is disabled right now. It's being turned off, although for some reason it's at 5 volts. Ah! And when somebody puts an awe emote into chat, the microcontroller turns on the power to the voltmeter, charges up to 100 volts, and then pops off. Although it's not kicking as hard as the 35 volt. So I'm a little concerned about that. I think maybe I need more caps, or maybe we need to give this a mechanical advantage, because at 100 volts, we're getting a pretty good pop off. So I think, and again, maybe I need to design some of the mechanicals around this, because we're losing a lot of energy in sort of this thing doing that. But it is pretty cool. I think having it kick a little bit more vertical so that the emote lands in the middle of what I'm working on would be the goal here. And then, of course, I need to have this thing on prominent display. Maybe it needs to light up red. I could put a yellow light in it and then have it go red when it's fully charged. That would be controlled by the microcontroller, though. I'd have to figure that one out. And then we'd be kind of commingling our 100 volt and our low volt or 3 volt space, which I guess is okay if I make this thing just work off of a power supply, a little 12 volt power supply. Our total current draw is 10 milliamps. Holy shit. It's like nothing. It's drawing nothing. But yeah, setup successful, circuit successful. One of the simplest switching circuits that you can have in electronics, using a Darlington in order to perform high current work. And the ESP is just simply triggering the Darlington. The Darlington consists of a small transistor and a large transistor, and the small one is there to kick off that large one with the higher voltages. 100 volts is nominal for this transistor. Everybody kind of gets to cool down in between things, although I'm wondering why this is still hot. When it's shut down, it really shouldn't be that hot. Although we haven't given it much of a chance to cool off today, so. Aussie coffee is better than the States. I hope you're not drinking like Seattle's Best, which is what we used to get at work, is awful coffee. We have some pretty good coffee here. You just have to search for it. I think people don't realize that about, like, yeah, see, look at that. That was pathetic. I don't think people realize that, like, with the American stuff, it's not just like if you just get like the fast food shit, it's gonna be bad. Like, you gotta like look for the good stuff. I don't know. You know this. You know this as much as I do, because you're between the two all the time. My favorite coffee is locally roasted. Yeah, stuff like that, man. There's a lot of good stuff like that. I'll have to figure out the mechanics of popping this thing away, because I guess it's not that strong. I mean, you'll see here. If we back up significantly, you guys can see exactly how powerful this thing is. Most of our coffee is imported. We're about to find out. Oh, you could use this to serve coffee in milliseconds. Yeah, and I've already got a hot plate. How pathetic that was. Does this thing get loose? Ah. The cool thing about this, though, is that it's safe in between firings. Oh my God, there's emotes everywhere. They're all. This is. It's a bloodbath. Oh my God. The huge manatee. Figuring out like a little hopper for these will also be a fun thing to do. Either a hopper or something that like serves them up. But what I want it to do is have the emote visible and facing me, so that if it's seen on camera. I miss those stools. These are the 1960s stools from my grandfather's farm. And I fixed these. I had to put brass inserts, thread inserts, into the bases because they've gotten so soft, and they've been repaired so many times to varying degrees of success. So now they are going to be, you know, good forever because of those brass inserts. How did you get electrocuted? I was trying to catch an emote that was flying around. I guess if it's facing upwards, it's a little better. It's picking up every hair on the shop floor. Did you ever get poison ivy? No. I got to shoot a Luger. That was the first real firearm I ever shot. I think he sold it. I don't think anybody has it anymore. I remember loading the rounds in hurt my thumb a lot. This is pathetic, Bother. This is what your stream has become. Listen, if it's entertaining them, I don't care. It should be good to go. I don't know why it drops them every now and then. But this is the best part, is that we go down to safe levels. Like a baby with car keys. I should put Mega on the list too. It's losing energy. The mechanics are changing. I've got it leaning back right now, and that boils away a significant amount. Tiny toy truck from 1914, an ounce of silver. I think I also got an ounce of silver. I think I have that sitting over on the shelf. Ah! Excuse me. Pez dispenser is one way to go. Literally just stacking them up like this is another way to go, so that the one on the bottom just gets flung and the other two fall down. But I think funnier would be if I could somehow have it slide up from the side. We put like a little gear motor and a little belt on it, and it'll just slide in from the side and then get knocked off. Hey, I was trying to do an example. This is a fairly violent kick. I think having it be at like an upwards angle is going to be the best way to do it, because it'll kick them upwards. And what I really want is that effect where on camera it'll fly up and arc. I want it to arc. A Benelli M4. I went to the firing range with my buddy, and he's got this technically legal machine gun. It's one of these deals where, you know, like with paintball, the big craze was to have a little bit of the gas, the CO2, kick the trigger back. And so you'd pull the trigger again, and technically that would be 2 trigger pulls, right? Because it's supposed to be 1 shot per trigger pull. You don't go above that in paintball. They found out that with the laws for guns, 1 trigger pull per shot, if it kicks you back a little bit, is apparently a thing. So I got to test my friend's gun like that. So technically, it's the first time I ever shot a machine gun. Pennsylvania is a very strange place. That'd be very cool for sure. He has it in a platform that is incredibly stable. So it was like a laser beam. It was really cool. Like normally you find your sight picture and you'll get kicked away, right? This thing, it just kind of barely pushes you up into the side, and you're just like, whoa, 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 whoa. Okay, let's go back down. Not like bump fire. Bump fire is when the recoil of the gun is acting like your spring, and you keep your trigger finger in the same spot. This is, you pull back the trigger, and it's sort of, and so you can actually control the rate of fire with how you're gripping it. I didn't find that to be the case. I would have to get more used to it. I was nervous. I was at the gun range. It was a good time. But yeah, my Tippmann A5, the paintball gun, paintball guns are not guns, they're markers. Even though I watched some competitive paintball recently, I was flipping through channels, and I was like, hey, they called it a gun. But what mine did is, with a little bit of the CO2, it would kick your trigger finger back. And so you're able to kind of with it. It's similar to the bump stock, but it's much more controllable. It's just like it feels like just a normal, I guess, machine gun. I don't know what a normal machine gun feels like. What am I talking about? But yeah, if I spent thousands of dollars, I could also do that. But I don't want to spend thousands of dollars yet. And I'm sure, like, next week it's going to be illegal. That's how those things happen. All right, so success today, right? We made something where if somebody types the awe emote into my chat, oh, the electronic ones, yeah, those were crazy. Those were crazy. And then everybody went to the beads, whatever that is, those things. Technically legal reminds me of when my dad decided to hook my car horn to a doorbell on my Volvo 240. We did a lot of that stuff on the Babe Rally. Actually, right now I only have one working windshield wiper. I need to go fix my car. But one thing we had on it was Big Apple to the Big Easy. It was a week-long road trip down the East Coast in cars that cost no more than $250. And the whole purpose of it for the Americans, because for the Brits, I guess they must do things a little bit differently, because for the Americans, we're all working together to get these $250 cars all through these challenges going down the East Coast. So there were like dirt roads, the Deals Gap, the 350 turns in a couple miles, all that stuff. There was like a take pictures of mailboxes challenge. One day we all had to dress up as Superman and descend on one of 3 of these very rural, sort of hard to get to southern towns. So you would pull into a gas station in these weird looking cars, get out in a Superman costume. Some of the people would just get in their cars and leave. Others were tickled pink. My son wants a picture with Superman's. But yeah, so that was amazing. One of the more common fixes that we had was, one, putting a switch on the fan that cools the car. Because almost universally in a $250 car, the fan would not work. So you would put that on a switch on the dashboard. So you're driving along and suddenly you get to city driving, non-highway driving, and you have to turn that sucker on and off or your car is going to overheat. The second most common repair was to take a speaker wire and to loop it out the side windows to the windshield wipers. And so you and your teammate would pull intermittently or in tandem or whatever on these speaker wires in order to get the windshield wipers to do anything. It was a lot of fun. I'm so nervous about like reaching over for stuff because I've got 100 volts. I don't have 100 volts actually, but there's the potential where if I get a little too cocksure about this thing, all of a sudden, it'll be at 100 volts. We can make this work though. I think we can make this work. I don't know if a smaller solenoid would do the job better. Or if I need to like, I don't know, multiply the force somehow. I don't know if I have a lockout on it. Are you going to have an autoloader? Yeah, I want it to be silly. I want the emote to like slide in. We'll figure it out. All right. I'm turning it off. See, and there's the drop in voltage when we remove the 12 volts. I think there's leakage through this. Maybe if I get rid of the resistor, it'll turn off a little bit more cleanly. There's still some stuff to do with this. We'll need to have another session with it. At least I know that those capacitors are no longer charged. And then just in case, take a piece of inductive material. Okay, that's definitely off. Ooh, that was, listen, guys, I don't do a lot of stuff with high voltage, right? 100 volts is a pretty sizable amount of current. And even at a couple milliamps, it can do some damage. So we did this perfectly, and I got to let you guys see from napkin drawing all the way to fruition how to deal with high voltage. So keeping away from it, keeping your limbs from crossing over the areas, sort of having a keep out area of all the stuff you're doing, making sure that you're powered down and discharged in between configuration tests. We were able to get something that gives a trickle charge. It's not really as much of a trickle as I would have liked. I wanted it to be like, and then pop. But that, I mean, the speed of that's pretty good for the amount of emotes that you guys are able to put into chat. So having it go zoop, pow, that was awesome. And it worked perfectly. That was a great Friday project. I'm super glad you guys joined me for that because boy howdy, if I had electrocuted myself on stream, I don't know if you guys know where I live. Is anyone else? The Idea Light. You guys can probably see it bouncing off of me. Discharge as in yeet a cable at it. Yeah. It's good practice to put like, what is it, like 100K, 150K big resistors across the leads of the capacitor. That way when power is off, it can discharge through that fairly quickly. You know, a couple seconds and it's all gone. But I didn't do that with this one. I did not do that. Why can't I expand unless the stupid Twitch window? I need to switch to Firefox on this computer. Not a lot. I see Garrick Durack. That's not in English. Boom is doing stuff. Summer, Gmart, Dex bonus, paleontologizing. Paleontologizing would be, well, I don't know if it's a fit for you guys. I don't see anybody doing nothing, so I'm gonna just close it up. We're just gonna shutter the windows and turn off the lights and not make any noise, and hopefully everybody will move on. Right? So the end card is inaccurate. I think my next stream's probably gonna be Tuesday. If I can, I'll do tomorrow, but I think I have other stuff that needs to get done, unfortunately. So where's Discord? We had a pretty good. I mean, I missed a stream this week because I was feeling like shit. Oh my god, Overwatch! Wow, hide this. I hate how you hide it and not permanently get rid of. Highlight that, and then the date of Tuesday. Tuesday is the 25th. Oh my god. March 25. 2025. Yeah, maybe I'll get a haircut tomorrow. I really need a haircut. All right. So I'll catch you guys. Oh, yeah, I need to actually do the end card. It's got the links to any social media that I have. Social media is very unhealthy for you, but if you want to see me on Blue Sky, you can see me there. Or if you want to catch me on Discord, I'm constantly on Discord. It's a problem. I will talk to you guys later. Have a good weekend. That's all I got. That's it. That's everything.